Okay, cool guys. Please solve one example of bubble sort with user input. Shravan, can you try this thing? I think that there is nothing different, right? There is nothing different here. It's basically the same thing, right? We have studied about taking inputs from the user, right? How do we take input of an array from the user? And then we understood how to do bubble sort on an array, right? So the entire process remains it remains the same, right? You can try it once on your own. And if you are unable to do it, then we can take it up. Okay. It's simple. It's simple. Cool. So I think we can get started. How many folks we have? Yes, we'll explain adaptiveness once again. I will take it up, right? I'll take adaptiveness once again. Okay. So I think many people are enjoying Saturday or whatever because we have a less drop today, I think, right? We generally have 400 plus people. Today we have only 300. But anyways, I think we'll get started and people can catch up, right? Cool. No dream abroad. Bubble sort cannot be done in big O of n. The best case can be big O of n, but the worst case is big O of n square. So if somebody asks you what is the time complexity of bubble sort, it's always big O of n square in the worst case, right? I can always give you an input that it takes n square time and not runs in n time, right? Cool, guys. So let's get started, right? So yesterday we covered bubble sort in entire detail. And today we are going to cover insertion and selection sort. Okay. So let's have a look. Yeah, guys. Can we solve this today? Let's see how much time do we have, right? Yeah, 8 to 11 today, right? So we'll get started with the concept of insertion sort, right? I'll try to go slowly so that everybody understands. But yeah, just try to pay attention also so that, it becomes clear a little bit faster for you guys as well. Okay. So yesterday we had a look at the entire, bubble sort algorithm. How many passes bubble sort needs, how many comparisons, how many swaps, what is the worst case time complexity, space complexity, stability, adaptiveness, right? Everything we discussed for bubble sort yesterday. Now, today we will start with a different sorting technique, which is known as insertion sort. Okay. Now, let me take an example to help you guys understand what exactly is insertion sort or how insertion sort actually works, right? So let us take the same array. Let us take the same array that we had taken yesterday, right? 8, 5, 7, 3, 2. Okay. So this is an array of integers that is available to me. And I want to sort this array of integers. Okay. And the algorithm that I will be using to sort this array is basically insertion sort. Okay. Which sorting is mostly used? It depends. 90% of the times you will be using an inbuilt sorting technique, which we will also talk about, right? But I'll answer this question a little bit later. When to use what sorting technique? Okay. Now, so we want to sort this array, and the technique that I will be using is insertion sort. So how does insertion sort actually work? So first of all, I tell you, boss, this is an array of size 5. Okay, I'm not drawing the boxes, but I think everybody understands that, yes, this is an array of size 5. Now, if I ask you, consider this one element 8. Consider this one element 8. Can I say to the left of the dotted line, the array is sorted? If you just have a look to the left of the dotted line, you just have one element. And if you have a single element, that part of the array is already sorted. एक single element में what sorting you want to do? Nothing. So this part of the array, the left part of the array, the left to this dotted line, that is already sorted. Now what I will do, the idea that insertion sort works on is you will pick up elements one by one. I will pick up elements one by one, starting from index number 1. See guys, this one element is already present in the sorted array. So what I will do, first of all, I will pick this element 5. I will pick this element 5, which is present at index number 1. And then what I will do, I will insert this element 5. ध्यान से सुनो. I will insert this element 5 in the already sorted part on the left hand side. Okay, I will take this number 5 and my job will be to insert this 5 in the already sorted part of the array on the left hand side so that the array remains sorted. Okay. So I will be inserting 5 at its correct position. Okay. So let me take some different, pen colors so that it becomes easy, right? So first of all, I am at index number 1. First of all, my I is equal to 1. What does it mean? It means that I want to insert the element that is present at index 1. Okay. I equal to 1 means I want to insert the element that is present at index number 1. Okay. Now what I will do, I want to insert this 5, right? Let us see how we can actually come up with a logic. Okay. So what will I do? What will I do? See guys, I keep a pointer j. Okay. I keep a pointer j. I keep a pointer j equal to I minus 1, one place to the back. Okay. मैं क्या करूंगा? Now what I will do, see guys, try to think of it कि this is a person. If you can understand it like this, think of it कि it is a person. What will happen? You compare 8 with 5. You compare 8 with 5. ऐसा समझो these two are people, right? You compare, and what does this person say? Boss, I am smaller than you. This number says, hey 8, you know what? I am smaller than you, so I should come in front of you and not behind you. ऐसा सोचो guys, I'm just trying to make it more, easy to understand, right? Think of it that this is a person 8, and think of it that this is a person 5, right? You want to insert 5. You want to insert 5 at its correct location in the already sorted part on the left hand side. So what do? I start comparing. Okay, I start j from I minus 1 and I compare. I compare 8 with 5. 8 is greater than 5. That means 5 should come before 8. So what should I do? I will swap 5 and 8. Okay. So after swapping, how does my system look like? 5 goes here, 8 comes here. Okay. And then what I will do? When I do a j minus minus, j comes here. Okay. That is at minus 1. So now tell me guys, I have compared 5 with 8 and I swapped. Okay. Can I compare 5 with any other element? Can I compare 5 with any other element? No more elements are left, right? So my job is done. So I will say, boss, you know what? One pass of insertion sort has been performed. And after one pass of insertion sort, you will see that I have successfully inserted 5 at its correct location. And now these two elements are sorted. Do you all agree? Do you all agree? These two elements are sorted. Okay. So first pass of insertion sort has been done. You have successfully inserted this 5 in the correct position on the left hand side. Now what do? Now I start the second pass of insertion sort. Okay. We swapped 5 with 8, right? We swapped 5 with 8. Okay. Now what I will do, guys? I know that these two elements are already sorted, right? So now can you tell me what element should I insert? What element should I pick for insertion? At index number 2. So now my value of I will become 2. Ki boss, I will take the element at index number 2 for insertion. Okay. Then what I will do? Think of it like he is a person. Okay. And now he will compare himself with the persons ahead. So what we will do? I initialize a pointer j. Okay. J equal to I minus 1. And then what I will do? I compare ARR of j. ध्यान से सुनो. I compare ARR of j with ARR of j plus 1. That is, I compare 8 with 7. And what does 7 say? 7 says, hey 8, I am smaller than you. I am a kid, right? So can you let me to come in front? So what will you do? You will swap 8 with 7. Swap 8 with 7. So after swapping, what happens, guys? Let us try to understand. 5 is here. 7 comes here. 8 goes here, right? And now what you will do? Now what I will do? I will do a j minus minus. I move j forward. Next, what I will do? I again compare ARR of j with ARR of j plus 1. That is, now I will compare 7 with 5. I compare 5 with 7, right? And what do I see? I see that ARR of j is less than equal to ARR of j plus 1. See, I see that 5 is lesser than or equal to 7. So what I will say? See, when this person compares himself with 5, he will say, hey, I am bigger than you. So I will stay here only. So I will stop this iteration. Can't get it. Okay. Let me repeat. Let me try to repeat. Okay. Let's come back again. So this is my original array. Okay. This is my original array of integers. Now, what do I tell you? What do I tell you? Just imagine this dotted line. Just imagine this dotted line. Forget I and j at this point of time. Just forget I and j, right? Just forget this. So this is the dotted line. Okay. And to the left part, my array is already sorted. Now, First of all, I will do the first pass of insertion sort. Okay. I will do the first pass of insertion sort. And what happens in the first pass? Can anybody help me? See, I will be inserting elements one by one. I will be inserting elements one by one. So what elements do I pick up for insertion? What element do I pick up? Can anybody help me on the basis of the logic that we have discussed? I will be inserting this element. I will take a 5 and I will insert it at its correct location. So I choose the element at index number 1. Okay? Now what do? I want to insert it at its correct position, right? Yes, we have to take the left part to compare elements, right? So now what do? I make a pointer. Let's say I make a pointer here. Okay, this is J. Okay. Now what I will do? I compare ARR of J with ARR of J plus 1. So I will compare 8 with 5. And what does 5 see? That 5 is smaller than 8. So what I will have to do? I will swap. Guys, देखो ऐसे सोचो कि this is a person, right? And this person wants to move forward. See, this is a person. ऐसा सोचो कि this 5 is a person and 5 wants to move forward as much as he can in the line. Okay. This person wants to go forward as much as he can. So what do? I first of all compare 8 with 5. 8 is greater than 5. So 5 will say, hey 8, I want to come in front of you. So what I will do? I will swap 8 with 5. So when I swap 8 with 5, what happens? The situation is something like this. Okay. Now the person has come here. Now, is there any other element to compare 5 with in the front? He wants to move in the forward direction, right? इसके आगे और कोई element है क्या? There are no more elements, right? So now I say, boss, 5 has reached at its correct location at this point of time. So now I say the first pass of insertion sort has been performed. And after first pass, what has happened? I have inserted 5 at its correct position, right? But you see, the intermediate results of insertion pass or insertion sort don't have any physical significance, right? Does this array mean anything to you? See, in one pass of bubble sort, we knew that the heaviest element will be at its correct position. But after one pass of insertion sort, you cannot say anything definitively, right? So the intermediate results of insertion sort are of no use to us. But after one pass of insertion sort, can I say these two elements are in the sorted order 5 and 8? Can I say? Yes. Everyone following till here? Okay. Now I will go to the second pass of insertion sort. Okay. So 5 and 8 are sorted. You have 7, 3, and 2. Now what I will do? In the second pass of insertion sort, what do? I will take this element for insertion. Okay. So what I will do? I initialize a pointer J here, one place to the back. Okay. And what I will do? Again, this person wants to move forward as much as possible. So I compare ARR of J with ARR of J plus 1. So I compare 8 with 7. And 7 sees that, boss, I am smaller than 8. So what I will do? I will swap 8 and 7. So how does the situation look? 7 comes here, 8 goes here. Okay. And 3, 2 are here. Now, 7 will try to move forward. 7 will try again to move forward. Okay. So you have done a J minus minus. So again, I compare ARR of J, that is 5, with ARR of J plus 1, that is 7. So next I compare 5 with 7. And what do I see? I see that, boss, 5 is lesser than or equal to 7. So should I move 7 forward? No, 7 is at its correct position. So I will stop. And I say, boss, the second pass of insertion sort has been performed. And after the second pass of insertion sort, see what has happened? 5, 7, 8. These 3 elements are in sorted order. Do you all agree with me? Yes? Correct? Okay. So let me take a different element here just for your clarity, right? Let's take a 6 and a 2. Okay. Now I will go to the third pass of insertion sort. Okay. Now what is the element that I pick up for insertion? Index number 3, that is 6, I will pick for insertion. Okay. So I initialize a pointer J one position to behind. Okay. And what do? I compare ARR of J with ARR of J plus 1. Okay. So see, my job is I will try to push 6 forward as much as I can. Okay. So I will compare 8 with 6. Okay. I see that 8 is greater than 6. So what I will do? Yes, I have changed the numbers, right? 3 2 ke jagah 6 2 le liya. Okay. So 8 is greater than 6. So what do? I perform a swapping. Okay. Now, kind of, not exactly opposite, I would say. Selection sort is opposite of bubble sort, right? This is not opposite. The basic intuition is different here, right? Okay. Now 6 has come here, right? Now, what is the next element that you will compare 6 with? See, earlier I was comparing j with j plus 1. Now I will have moved j one position behind. Again, I will compare ARR of j with ARR of j plus 1. So I compare 7 with 6. And I see that ARR of j is greater than ARR of j plus 1. So what I will do? Again, I will push 6 forward. I will swap, right? So 5, 6 goes here, 7 is here, 8 is here, right? Next, again, I will do a j minus minus. So j has come here. Now what I will do? Again, I compare ARR of j with ARR of j plus 1. I compare 5 with 6. Now I will see that boss 5 is less than equal to 6. So should I move 6 forward? No, there is no need to move 6 forward. So I will break from here. I will simply break and I will say, boss, the third pass of insertion sort has been performed. And after third pass of insertion sort, these 4 elements, 5, 6, 7, 8 are present in the sorted order. Do you agree? Yes? Okay. So 5, 6, 7, 8 are sorted. Now I will perform one more pass. I have to perform one more pass. That is the fourth pass of insertion sort. And what is the element that I will take for insertion? 2. Let's get started, right? This is the element that I take. I put a pointer here, j. Okay. I compare ARR of j with ARR of j plus 1. I compare 8 with 2. See, first try to understand the algorithm, right? Once you are clear with the algorithm, we can be in a better position to understand the code more easily. Okay. So, pehle algorithm samjho, then we'll go to code. Okay. I compare 8 with 2. 8 is greater than 2. So, what should I do? I should swap. Okay. Then what do I do, guys? And after swapping, what happens? J minus minus to ho hi raha. Okay. Again, I compare j with j plus 1. So, I compare 7 with 2. Okay. Again, I see that 7 is greater than 2. So what I will do? I will again swap. So now what happens? 2 is here. Okay. Now 2 has come here. Again, I will again compare ARR of j with ARR of j plus 1. Okay. So 6 is greater than 2. I again do a swapping and then do a j minus minus. So what happens? 2 comes here, 6 goes here, 7, 8. Okay. Then I will compare ARR of j with ARR of j plus 1. I compare 5 with 2. I compare 5 with 2. Right. Again, I will swap. So what happens? Okay. And then when I do a j minus minus, I see that j has gone to -1. Okay. So now my array, the fourth pass has been done, right? And after 4 passes, can I say my array has been sorted? Guys, one element was already sorted and you did an insertion for 4 times. So definitely your entire array has become sorted. Okay. See, it is not exactly the opposite of bubble sort, right? Because in the bubble sort, the intermediate steps made significance. They were meaningful results, right? But here, the intermediate steps, okay, at the end of the first pass or the second pass, you don't get any meaningful result. Okay. But yes, is the algorithm making sense, guys? You will pick up elements one by one and you will try to, move it forward as much as they can. Okay. Algorithm is clear to everyone? Yes, clear till now? Okay. So let us try to develop a basic code for this algorithm, right? Now, once we develop the code for this algorithm, then we will discuss the time complexity, space complexity, adaptiveness, stability, code it up and go to the visualizer. Okay. See, the importance of intermediate steps is in bubble sort, right? If I said, boss, one pass of bubble sort has been done. If I tell you one pass of bubble sort has been done, then you know that heaviest element is at the end. But if I tell you one pass of insertion sort has been done, I don't know whether I know that 2 elements are sorted now, but are they at their correct locations? I cannot tell you guys. Because they can move further. They can move behind in the future as well. Right? Cool. So let us try to develop, an algorithm for insertion sort, a code for insertion sort, right? Why should you know? It's always good to know things, right? See, the major purpose of learning these sorting techniques are, na, I will tell you later. But the thing is, there is an inbuilt sorting technique. Okay. Then you will ask me, why are we learning these things? But the thing is, when you use arrays.sort, I will tell you, right? This is the inbuilt sorting technique. When you use this now, the entire array will be sorted. You cannot stop sorting in between. भाई ध्यान से समझो, if you call an inbuilt technique ना, जो already coded है, it will sort the entire array. No, it is the most efficient, but it will sort entire array. If you want to stop in between, you will not have that flexibility and control. Okay. But if you know your own sorting techniques now, you have that control. If I want to stop after 2 iterations, I can. Okay. And the second thing is, in interviews also, in interviews and coding tests, sometimes interviewers want you to write your own sorting techniques. They want to see how much you can think, right? And just not depend on the inbuilt sorting techniques. So it is always good that you know these sorting techniques. Okay. Difference. See, the difference between bubble sort and insertion sort is their algorithms are completely different, right? Bubble sort basically settles the heaviest element at the end. But the technique of insertion sort is highly different. See, the basic algorithm or the basic approach only is different, right? This time I am inserting elements in the already sorted part on the left hand side. So that is one fundamental difference. And the other fundamental difference is that bubble sort, the intermediate results make sense, but insertion sort, the intermediate pass results does not make sense. Okay, cool. So now let us try to develop a code and then we'll go into analysis of the algorithm, right? Okay. So can you tell me, guys, can I tell you one thing? If you have an array of n elements, how many passes of insertion sort do I need? In one pass, I will be inserting an element. How many passes of insertion sort do you need? You need n minus 1 passes of insertion sort. Everyone agrees? Yes. And what we will be doing? First of all, I will insert the element at index number 1. Then I will go to index number 2, insert the element that is present there. Then I will go to index number 3, insert the element that is present there. Till I will come to index number n minus 1 and insert the element that is present there. Do you agree? The element at index 0 is already sorted. First of all, you go to index 1, insert the element. Go to index 2, insert the element. Go to index 3, insert the element. Go to index 4, insert the element. Do you agree with me? This is what we are trying to do. Yes. Okay. So let us try to develop a code, right? Let us try to develop a code. Okay. So I write a loop, right? I write a loop for int I is equal to 1, I less than n, I plus plus. Can you tell me the significance of I? Looking at the loop, kahan se kahan loop run kar raha hai? First of all, I will take a value of 1. That is, I want to insert the element at index number 1. Then I will take a value of 2. I want to insert the element at index number 2. Then I will take a value of 3. I want to insert the element that is present at index number 3. So I is telling you what is the element you want to insert. So can I tell you the element that you will be inserting is ARR of I? Do you agree? First of all, I will take a value of 1, then 2, then 3. See what we were doing, guys. Try to understand. If you have an array of size 4, right? Then first of all, you came to index number 1 and you inserted this element, right? Then you came to index number 2, you inserted this element. Then I came to index number 3 and I inserted this element on the left hand side, right? So I will start from index number 1 and go all the way till end. Do you agree? See, what is the meaning of I? The meaning of I is pointing to the element which you want to insert. So from where do you start inserting? Come to the basic insertion sort. मैं क्या बोलता हूँ, boss? The element at index 0 is already at its correct position. So I start inserting the elements from index 1 now. Look at the insertion sort algorithm. What was the first element that I inserted? The first element that I inserted was 5. Then I inserted 7. Then I inserted 3. Then I inserted 2. So first of all, I inserted the element which is there at index 1, then index 2, index 3, index 4. So I start from index 1 and go all the way till the end of the array. Do you agree? समझ आ रहा है? How many of you understand? Yes? Okay. So this is And if you understand, right, this loop, how many times will this loop run? How many times will this loop run? Can anybody help me? N minus 1 times, correct. So this will perform n minus 1 passes of insertion sort. Correct, guys, correct. Thank you. So now forget about this. Now what do I want to do? Now what do I want to do? Let us come back to our logic, right? Now, see, let's say that I wanted to insert this element. So what did I do? I initialized the pointer j is equal to I minus 1. Okay. See, abhi to j aaya bhi nahi hai, boss. Just wait a little bit, everything will be covered, right? Now, what did I tell? I want to insert the element which is present at index number I. Yes, Anish, I am telling you the same thing, right? We haven't discussed anything new. Okay. So I want to insert the element at index number I. So what do I do? Anybody? I want to insert this element. Okay. I is pointing to the element that I want to insert. What do I do? I initialize the pointer j from here. And what was I doing? I was comparing ARR of j with ARR of j plus 1. Do you agree? Yes. So what I will do, I'll make a loop, okay? A pointer j will start from where? From index number I minus 1, okay? And till where should j go? See, I am comparing ARR of j with ARR of j plus 1. So till where should j come? Till index number 0, right? J should not go, at minus 1, okay? So j greater than equal to 0. And then I will say j minus minus. Now what do I do? I check if what two elements do I compare, guys? Can you help me? What two elements do I compare? I will compare ARR of j with ARR of j plus 1. Do you agree? See, j starts from here. What I will do, I compare ARR of j with ARR of j plus 1. Okay. And if ARR of j is greater, then I will swap. Otherwise, what should I do? If I see that ARR of j is lesser than equal to ARR of j plus 1, so I should simply break. That is what we were doing, right? So I check. If ARR of j is greater than ARR of j plus 1, okay? If ARR of j is greater than ARR of j plus 1, what should I do, guys? I will swap. What two elements? I will swap ARR of j with ARR of j plus 1. Okay? Swap kar diya, and then you will do a j minus minus. But guys, help me with one thing. If ARR of j is lesser than or equal to ARR of j plus 1, then what should I do? Yes, I'll repeat. What should I do? Break, right? The moment you see that ARR of j is less than equal to ARR of j plus 1, you simply break because you have inserted the element at its correct location. Okay? So just break. That's a very, very simple code for insertion sort. Okay? Repeat once again for sure. Let me give you a running. Okay, let's write the code and try to do a dry run, right? I think that will make it more clear. Okay, wait. Let's do a dry run, right? So J will start from, even if we don't put else, still it will work. It will work, right? But you will have to do extra comparisons. Why do you want to do that? Okay. It's best always to avoid that, right? Repeating, guys, repeating. Don't worry. Just let me write the code once so that you are able to follow. Swap. Okay, I'm just writing swap, you understand, right? Else, break. Okay. Else break. Yeah, fine. That's fine. Okay. Now let us try, right? Here we compare I with J. Okay. I wrote the code using 3 loops. Yes, it can get affected. We have to see the code for that, right? But let us try to understand, right? Let us try to understand using our example. 85732. Let us try to do a dry run with this code, okay? So first of all, I start. What is the value of I, guys? Can anybody help me? At the starting, first time the for loop runs, the value of I will be equal to 1. That is, I is pointing to this 5. Okay. Now what we'll do? For the inner loop start running. For int j is equal to I minus 1. So j gets initialized at index number 0. And what do I check? J greater than equal to 0. Is J greater than equal to 0? Yes, J is at index 0. That is fine. Okay. So what do I check? Is ARR of J is 8 greater than 5? See, J plus 1 is I only. Is 8 greater than 5? Yes, 8 is greater than 5. So what I will do? I will swap ARR of J with ARR of J plus 1. So what happens? 5 comes here, 8 comes here. Okay. I is still here. Okay. And J, ab kya hoga? After swapping, what will happen, guys? Can you help me? You swap and then you again go to the next iteration of this for loop. So a J minus minus will happen. And when you do a J minus minus, J ka value will become -1. So when you check -1 greater than equal to 0, no. So this for loop terminates. Does everyone agree? Boss, you are comparing ARR of J with ARR of J plus 1. See guys, try to understand. Again, we'll take one more, right? See, you are comparing ARR of J with ARR of J plus 1. Okay. If it is greater, you swap. Okay, मैंने swap कर दिया. And then you did a J minus minus. Now, when J's value has now become -1, so how can you compare ARR of J with ARR of J plus 1? See, if J is equal to -1, it is not a valid index, right? So you need to stop. Done. Now I will say, boss, you have successfully inserted the element that was present at index 1. Now what will happen? 5 is I. 5 is I, but is 5 not J plus 1 also? Is 5 not J plus 1 also? Correct, na? Okay. Now try to understand. This for loop terminates. Now what will happen? The value of I will increase. The value of I will increase. Okay? The value of I will increase. So where will I come? Achha, let us take it as 6. Okay? Okay. Now what will happen, guys? The value of I increases. So I plus plus हुआ. Outer loop 0 से क्यों नहीं चल रहा है? Kambir, what is the first element that you are inserting? The first element that you are inserting is index number 1 wala element, right? That is why I've started I from 1. Okay. Now, hey, if you want, you can do, right? See, if you want, you can definitely start I from 0. See, different persons can have different implementations, but the logic should remain the same. Okay. Now what will happen, guys? I plus plus happened. So what is the value of I now? Can anybody help me? What is the value of I? I has become equal to 2. So I is here, right? I is here. Now what will happen? This for loop starts running. What will J get initialized with? I minus 1. So where is J now? Can anybody help me? Where is J now? Where is J now? J is at 8. Okay. See, I is at index number 2. So J is starting at index number 1. Now see what do I do? I see, okay, this index is greater than equal to 0 for sure. 1 is greater than equal to 0. So I compare ARR of J with ARR of J plus 1. I compare 8 with 7. 8 is greater, so I do a swap. Okay. So 5 is here, 7 comes here, 8 goes here, 6 and 2 are here only. Okay. So swap has happened, right? Now what will happen, guys? Can anybody help me? Anybody? After swapping, what will happen? J minus minus. So now J comes here. Now guys, try to understand. Now J has come at index 0. Now what we were doing? Again, I will compare. See, 0 is greater than equal to 0. That is fine. Again, you compare ARR of J with ARR of J plus 1. So you compare 5 with 7. And what do you see? That boss 5 is less than equal to 7. So I enter into the else part and I simply break. Okay. Done this pass. I break. Now what will happen? The value of I will increase. Now I will go at index number 3. Okay. Now I will go at index number 3. Now I comes here. So I want to insert this element. And what I will do, J gets initialized with I minus 1. So J is here. Now what do? I am currently at an index greater than equal to 0. So I compare ARR of J with ARR of J plus 1. 8 is greater than 6. So what I will do? I do a swapping. Okay. I is here only, no problem. I do a swapping. And then what will happen? J minus minus. So J comes to this index. Next, what I will do? Again, I see. What is this index? Index number 1. So this is a valid index. So what I will do? I compare ARR of J with ARR of J plus 1. 7 is greater. So again, I will perform a swapping. So 6 comes here. 7 is here. 8 is here. 2 is here. And then you do a J minus minus. Now J comes at index number 0. Okay. Now again, J is a valid index. No problem. I compare ARR of J with ARR of J plus 1. And what do you see? that boss 5 is less than equal to 6. So you will simply break. No more comparisons needed. I will simply break. Done. Then the next loop, next iteration of I will run and you will do a I plus plus. So I will come here. Okay. Now I is here at the last index. Okay. And the inner loop starts running. Where will J get initialized? J starts from index number I minus 1. Okay. This is a valid index. You compare ARR of J with ARR of J plus 1. 8 is greater than 2. So I just perform a swapping. Right? And then J minus minus ho jayega. Then again, this is a valid index. I compare ARR of J with ARR of J plus 1. Okay. Again, you will do a swapping. And J minus minus happens. Okay. Now J is here. Again, I compare ARR of J with ARR of J plus 1. Right? 6 is greater than 2. So again, I will do a swapping. Idhar bana raha hu. And a J minus minus will happen. Okay. Now, again, J is at a valid index. You compare. Okay, sorry, I didn't swap. Okay. J is at a valid index. Again, I compare ARR of J with ARR of J plus 1. It is greater. So I do a swapping. Okay. So 2 comes here. 5, 6, 7, 8. Now what happens? Now when you do a J minus minus, you will see that J has come at index minus 1. And this is not a valid index, right? That is why the condition of the for loop was J greater than equal to 0. So now I see that the condition is false. So I come outside the loop. Okay. And when I do a I plus plus, I also goes outside the array. So the double for loops have run. And now my array has become sorted. Are you guys able to follow what is happening? क्या हो रहा है? Yes? Fine for all? क्या लेना है? I is less than equal to n. Yes, yes, yes. That you can take, right? Ultimately, I should get till the last index, right? Cool. So now I will ask you a couple of simple questions. Now you will only, explain to me. Else part not clear. See, try to understand. Let's say, I'll tell you the else part, right? 1 second. Correct. Let's say, okay. Now you are inserting 9. Okay. So J is starting at I minus 1. I compare ARR of J with ARR of J plus 1. It is greater. So I perform a swapping and I do a J minus minus. You will understand. Okay. Now J comes here. Now again, I compare ARR of J with ARR of J plus 1. Now see guys, 7 is less than equal to 9. So boss 9 is at its correct position. Because 7 is less than equal to 9. And all elements to the left of 7 will be lesser than equal to 7 only. Because the array is sorted. So the moment you see that ARR of J is lesser than or equal to ARR of J plus 1, you can simply break. There is no more need to move J to the left. That's it. Okay. Now, before I go and write the code, right, I want to do the entire discussion at once. Okay. So can anybody comment on the time complexity? Yes, you can also use while loop also. That is also fine. You will see that there are different implementations for insertion sort. Whatever you best understand, you can adopt that, right? Okay, n square. So everyone is saying n square. Does everyone agree with that? You have 2 nested loops, right? You have 2 nested loops. And see guys, if you think logically, what are you doing guys? What are you doing? When I am inserting the first element, at the worst case, how many comparisons would I have to do? 1 comparison. See, only 1 comparison. Okay. When I insert this element, I need to do 2 comparisons at max, right? Okay. So if you count the number of comparisons, okay, in the worst case, right? When you are inserting the last element, how many comparisons you might have to do? You might have to do n minus 1 comparisons. So if you add up the number of comparisons, you will see it comes out to be n into n minus 1 by 2. Another simple way of understanding, look at the loop structure. Okay. Just forget everything else. Just look at the loop structure. Whatever I am doing, I don't care, right? Now tell me guys, when the value of I is 1, how many times does the inner loop run? Only 1 time. Okay, see, I will start from 0, 0 greater than equal to 0, the loop will run once. Then when the value of I is 2, how many times will the loop run? 2 times inner loop. Okay. When the value of I is 3, how many times will the inner loop run? 3 times. Okay. Similarly, when the value of I is n minus 1, the inner loop will run for n minus 1 times. So if you add the total number of operations, it is nothing but n into n minus 1 by 2. Do you get this part? Yes? So if I ask you, boss, what is the number of comparisons in the worst case? In the worst case, n into n minus 1 by 2. In the worst case, right? And when this will happen? When the array is sorted in descending order. Okay, n into n minus 1 by 2 comparisons will happen. So in the worst case, the number of comparisons is of the order of n into n minus 1 by 2. So can I say the worst case runtime of insertion sort is big O of n square? Can I say? Yes, big O of n square time complexity. Everyone agrees? And what is the space complexity, guys? Big O of 1. Because I haven't used any extra space, right? I haven't used any extra space. It is the same array and I am doing swappings inside this array. So that is the space complexity. Okay. Now I will ask you a couple of questions. First question, is it stable? Is this algorithm stable? Think very carefully. Is this algorithm stable? The answer is yes, it is stable. Because try to understand, guys. Let us take an example, right? Let us take an example. See, I want to discuss everything at once and then go to code, right? So let us take an example, right? Let's say you have an 8 star, okay, and you have a 8 here, okay. Now let's say I am inserting this 8. Let's say I am inserting this 8. So what are we doing? See, guys, when I compare same elements, what are we doing? What have we written? If ARR of J is greater than ARR of J plus 1, then only I am swapping. I am not swapping the same elements. So if I am not swapping the same elements, then can I say the relative ordering of the same elements will remain maintained? Bhai, dekho na guys, try to understand. Let's think of it like this. 1, 2, 8 star, 9, 10. Okay. And you are inserting this 8. Okay. 8 star was before 8. Now I am inserting this 8. So what will happen? I compare 10 with 8. I do a swapping. Okay. So 8 will come here. 10 moves here. I compare 9 with 8. 9 is greater. I do a swapping. 8 comes here. 9 comes here. Now when you compare this 8 star with 8, will you do a swapping? Never. Never. Okay. Because I was only swapping if the element is greater than its next element. So definitely for the same elements, the relative ordering will never be disturbed if you use this condition for swapping. So can I say the insertion sort is stable? No, it's not about break. It's about the swapping condition. Okay. You are swapping if ARR of J is greater. Agar main yahan pe equality introduce kar do na, then it is an unstable sorting algorithm. But if I remove this equality and I swap only when strictly greater, then it is a stable sorting algorithm. Is it making sense, guys? Yes, two same elements does not swap. So the relative elements ordering will never get disturbed. Okay. Cool. Now, I ask you another question. Boss, is this algorithm adaptive? Is it naturally adaptive? Or do I have to synthetically make it adaptive? Tell me. Chalo guys, logic dekhte hain. How do I check if it is adaptive or not? Take a sorted input. Take a sorted input. Okay, I've taken a sorted input. What you will do? You start your I from here. Okay, you start your I from here. Okay, J starts from here. I do a comparison and I will simply break. Okay, so for I equal to 1, how many comparisons have I done, guys? Can anybody help me? How many comparisons have I done? Only one comparison and then you break. Do you agree? Do you agree? You do one comparison and you break. Okay, then you do a I plus plus. Your answer lies in the logic itself, right? Now again, J starts at I minus 1. I do a comparison of 2 with 3 and I see that 2 is less than equal to 3. So I again break. So for I equal to 2, how many comparisons am I doing? One comparison. So you will see if the array is already sorted, how many comparisons are you doing? Total you are doing n minus 1 comparisons. So best case of insertion sort is big O of n. Okay. Try to understand, guys. Try to understand what actually happens for I equal to 1, I less than n. What is adaptive? Adaptive, I had discussed it yesterday. If you give a sorted input, it should run in lesser time complexity. If that happens, it is adaptive. Okay. Now look, for You started j at I minus 1, okay? J greater than equal to 0, j minus minus, okay? And we had the condition ki boss, if ARR of j is lesser than equal to ARR of j plus 1, then what I was doing? I was simply breaking, coming out of the loop. Else we were performing a swapping. Everyone agrees? This is what we were doing, right? Now think of what happens if the array is already sorted. I equal to 1. Okay, now the inner loop starts running. And what will happen? You will see that ARR of j is less than equal to ARR of j plus 1. So immediately you will see if the array is sorted now, if the array is sorted, immediately you will see ARR of j is less than equal to ARR of j plus 1. So you will simply break. So this loop runs only once. Okay. Similarly, when you go to I equal to 2, you will see that the inner loop runs just once and you simply break out. So this is just a dummy loop in that case. Okay. So can I say the total number of comparisons if your array is already sorted is big O of n minus 1, which is big O of n. So the best case runtime of insertion sort is big O of n. And insertion sort is naturally adaptive. Naturally adaptive. Okay. It is naturally adaptive. You don't have to make a flag or something like that to make it naturally adaptive. Okay. Once again explain. Okay. See, try to understand, guys. If your array is already sorted, see what is the meaning of adaptive? Ki when I give it a sorted input, it should run in lesser time complexity. Okay. Yes. See, it is just a theoretical concept. Ki is the best case better than the worst case? Something like that. Okay. So try to understand, if I give an already sorted array, what happens? First of all, I want to insert this. What you will do? I start j from here. I compare these two elements. I do this one comparison. And I see 8 is less than equal to 10. So I simply break. I simply break off the inner loop. Then what will happen? So for I equal to 1, you just had to do one comparison. And you know that yes, 10 is at its correct position. Then I will increase I equal to 2. And again, j will start from here. What do? You compare ARR of j with ARR of j plus 1. You do this one comparison. And I see 10 is less than equal to 12. So I will simply break. So for I equal to 2, again, you just start doing one comparison. Okay. Then again, you will increase I. Now I want to insert 13. And you will just compare 12 with 13. You see 12 is already less than equal to 13. So you will be done that yes, 13 is already at its correct position. Then I will insert 15. And when you compare 13 with 15, you see that 15 is already at its correct position. So whenever, yes, because of the break condition, it becomes adaptive, right? So what I'm trying to say is, whenever you are inserting an element, okay, if you are given a sorted array and you insert an element now, you just do one comparison and then you will break. Okay, so it is adaptive. Okay. Is it making sense, guys? Yes. Okay. Now let us, why the best case big O of n? No, chalo, omega of n le lo. Koi dikkat nahi hai. Best case omega of n. Okay. No problem. Okay. So if I want to summarize, before going forward, okay. If you have n elements, how many passes, guys? How many passes do I need? I just want to summarize everything. N minus 1 passes needed. Okay. Now, in the worst case, how many comparisons? In the worst case, the number of comparisons will be n into n minus 1 by 2. Okay. And the number of swaps will also be n into n minus 1 by 2 in the worst case. Same. Right. So the worst case runtime is big O of n square. Space complexity, big O of 1. Is it stable? Yes, it is stable, because similar to bubble sort, we are swapping the adjacent elements only in case of strict greater than. So we are never swapping two equal elements. Thus, their relative ordering will never get disturbed. So it is stable. Is it adaptive? Yes, it is adaptive, because if you give it a sorted input, for every element, you do one comparison and you break. So if you give it a sorted input, the best case runtime will be omega of n. So it is adaptive. It is adaptive, right? Okay, cool. Let's move to the code. Can in any case, worst case scenario give us better time complexity than best case? No, never. How can it be? Worst case to hamesha best case se kharab hi hoga na. If we take a while loop, still it's adaptive. It depends on what kind of logic you are writing, right? With the while loop also, it can be adaptive. Okay. At the end of the day, it depends on what kind of algorithm you are writing. Okay. Let's come back. Okay. First of all, do you want to look at the visualization or do you want to look at the code? Visualization. Let's quickly look at the visualization. Okay. Then we'll go to code. Visualization देख लेते हैं एक बार, सबको clear हो जाएगा एकदम बढ़िया से, है ना? Okay. So this is the array that is given and we want to do an insertion sort. So first of all, what element do I insert? देखो, highlighted element says that it is already sorted. And do you agree that 8 is already at its sorted position? See, highlighted green records to the left are always sorted. See, a single element is already sorted. Now I want to insert 575. This is the element that I want to insert. Okay, chalo karte hain. I compare 80 with 75. Okay, and it was already lesser. See guys, kuch nahi kiya ye. Kyun nahi kiya? Because 80 is already less than equal to 575, right? So I will simply break. And I know that yes, now my pass number 1 has been done. Do you agree? Everyone following till here? Yes. Now the next element that I want to insert is 152. Let us do the comparison. Okay. I will compare. Okay. I will compare 152 with 575. Okay. See, move the blue record to the left until it reaches its correct position. So 575 is greater. So I will swap. Okay. Then what I will do, I will compare 80 with 152 and swapping will not happen. Okay. Because 80 is less than equal to. So I know that 152 is at its correct location. Next, I will insert 205. Okay. So I do a comparison. 575 is greater than 2. This. So I will do a swap. Again, I will compare 152 with 205. 152 is less than equal to 205. So 205 is at its correct position. Next, I will insert 397 and see what happens. Swap. And it is at its correct position. Then I will insert 739. 739 में क्या होगा? You do just one comparison with 575 and you will simply break. Because 739 is at its correct location. Okay. Then I want to insert 136. What will happen? First you compare with 739, swap. 575 के साथ compare, swap. 397 के साथ compare, swap. Again, swap. Compare with 152, swap. Now when I compare with 80, I see that 80 is less than equal to 136. So it is at its correct location. Okay, done. Next, I want to insert 17. Very beautiful, right? Swap. क्या होगा? Swap, swap, swap. 397 greater, swap. 205, swap, 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 right? Then I'll compare. See, now J is at index 0. I compare 80 with 17. Again, swap. Now, is there any further comparisons left for 17? No. Job done. See, the entire array has become sorted. Is it making sense, guys? How space complexity is big O of 1? See, space complexity is big O of 1 because we haven't made any extra data structure. We have just used the swapping technique, right? We are swapping the elements in the array itself. Okay. No, Vishwal, and that is just another way of writing the same thing, right? Okay. So now let us come to insertion sort, right? Let us come to insertion sort. Okay. Think we'll just remove this. Okay. And see, guys, you know, I am just taking this example from Geek for Geek so that you also understand, right? So what it is doing, boss, you have to write an insertion sort. Okay. See, this is functions. We just have to complete the function. We don't have to care about anything else. We have to complete the function. Okay. I will give you the code without the function also. You all can write. I am pretty sure. Okay. Is there any case where space complexity changes or it remains big O of 1? Till now, whatever we are discussing, that is big O of 1. Okay. मैं बताऊंगा कुछ examples लूंगा where it goes beyond big O of 1. But that is later, not now. Okay. For adaptive, do we have to give the condition that if the array is sorted, then use break because in unsorted array with break? No. Why will it give the wrong answer in unsorted array? Never. See, break, you are breaking when you know that the element that you are inserting is at its correct position. Okay. Cool. Make dark theme. Average case, we don't really worry about. Okay. That's not needed. Okay. So guys, what it is doing, you have to write this insertion sort function. Okay. This is the array ARR given to us and N, that is the size of the array that is given to us. Okay. Okay. Or likhte hai. And they want us to write the insert function also. Okay. So what am I telling? I write something like this. Help me guys. Is it correct? I start iterating from where? See, you have to sort this entire array ARR that is of length n. Okay, that is of length n. So what I will do, I will start from index number 1 and I will go till the last index, till n minus 1. Okay. And what I will do, whenever I am standing at a particular index, what I want to do, I want to insert the element that is present at index number I. Do you agree with me? First of all, you would want to do an insertion of I equal to 1. Then you want to insert the element which is present at index number 2. Then you want to insert an element which is present at index number 3 and likewise. Okay. So can I say, boss, I want to insert the element, okay, in ARR, comma I. I will call insert ARR, comma I. What does it mean? Boss, I will take the element which is at index I and I will insert it at its correct position in the left part. Okay, do you understand what I'm trying to say? See, ये लोग और break कर दिए है, ठीक है? कि boss, write your own insert function. And what is this insert function expected to do? What is this insert function expected to do? This will take an integer I, which will tell me, boss, this is the element that you want to insert. Okay, I will give it an index. Boss, this is the element that I want to insert. Okay, and you will have to do an insertion of 8 in the already sorted array on the left hand side. Okay, so first I call insert for I equal to 1. That is, I will be inserting the element at index 1. Then I will call insert for I equal to 2. I will be inserting the element that is at index number 2. And likewise, I will keep on calling my insert function till I equal to n minus 1. Okay. Now, can anybody help me with the logic of insert? Can anybody help me with the logic of insert? I want to insert the element which is present at index number I. What should I do? What should I do? Can anybody help me? I want to insert the element. This insert function inserts the element which is present at index number I. क्या करूंगा मैं? Simple. Only J loop is required here, right? For int J is equal to I minus 1. I start from I minus 1. Till where should J go? J greater than equal to 0 and J minus minus. Then what should I do? I will compare, right? I will compare. Okay. If ARR of J is greater than ARR of J plus 1, then what should I do, guys? If ARR of J is greater than ARR of J plus 1, what should I do? I should perform a swapping. Okay. So let us take a temporary variable int x is equal to ARR of J. Then I will say ARR of J is equal to ARR of J plus 1. Then I will say ARR of J plus 1 is equal to X. Have I done a swapping? Yes. Okay. And after swapping, you do a J minus minus. But if ARR of J is less than equal to ARR of J plus 1, what do? I just want ki boss, your insert function has been done. Ho gaya, insert kar diya. So either you can break or you can also write a return here. Do you agree? If you write a return here, now this function terminates. That is, you are done inserting. Okay. Why are we using two functions? Because it was given in the problem. Okay. You can do it in one function also. Is it making sense, guys? See, here if you write a break, that is also fine. Because you break from this loop and the function terminates. Or you can also write a return so that the function terminates. Okay. Now, what is line number 65? Explaining. Line number 65 is basically what is happening. See, let's say you have an array. Okay. So I start from index I equal to 1. So I will call my insert function. I will say insert ARR, comma 1. The boss, I want to take the element at index number 1 and I want to insert it. And once this function runs, I will expect that the element 5 is inserted at its correct position. Aisa kuch. Okay. Then the value of I will become 2 and I will say, boss, can you insert the element which is present at index number 2? So I will call ARR, comma 2. ARR, comma 2. I will call the insert function on ARR, comma 2. So take the element at index 2 and insert it at its correct position. Okay. See, I'll try to explain. See what is happening. I'll dry run. 1 second. Okay. See, you have been given an array. देखो, main function लिखना नहीं है मेरे को, ठीक है? Main function is already written and somebody is calling an insertion sort. Okay, try to think like this. 8, 5, 7, 3, 2. Okay. Now what is happening? Somebody has called insertion sort from the main method. Can you do an insertion sort for me? Can you do an insertion sort for me of array ARR, which is of size 5? Okay. See, we don't have to worry about the inputs. We just have to write functions. Okay. So some person from the main method has called insertion sort. Ki boss, can you sort this array ARR? And the length of this array is 5. Okay. See, main function is hidden here. Don't worry. Main function is hidden here. Okay. Now, what happens? अब मैं start करता हूँ running this insertion sort function. So what I will do? For int I equal to 1. Okay, so I starts at index number 1. I starts at index 1. So what will happen? I call insert function. I call insert function ARR comma I. I call ARR comma I. So what it will do? I am telling, hey, can you insert the element which is present at index number I? So this function gets called. Now what will happen? See, the insert function now will start running and the value of I is 1. So what will happen? J will get initialized at I minus 1, that is 0. And see guys, this is the same logic. Try to understand guys. This is the same logic. Okay. Now what will happen? Again it starts running. You will compare ARR of J with J plus 1. It is greater, so you do a swapping. You do a swapping. Okay. Then you will do a J minus minus and you see J goes outside, so you will stop. Okay. So I just come outside the for loop and the function terminates. So now what will happen? See, this function has terminated for I equal to 1. Now the value of I will become 2. And again you will call insert ARR comma 2. The boss insert the element which is present at index number 2. Are you getting what I am trying to say? How many of you are understanding what is happening? Boss, you are just running over your array and you are calling the insert function for every I. So first you call insert for I equal to 1. So this element gets inserted. Then you call insert for I equal to 2. This element gets inserted likewise. Okay, leave it. If you don't understand, let's go to GDB. I think that's best, right? Let's go to GDB and quickly code it up, right? I see that you guys need more time for functions, I feel. Okay. Anyways, let's try to code in GDB, right? You have an array. I won't even make functions for the time being, right? You have an array. Okay. This is the array. Okay. Now what I want to do, let us write int n is equal to arr.length. ये code बताओ ये समझ आ रहा है या नहीं? Okay. Now I want to do insertions one by one. First of all, I will insert the element at index 1, then index 2, then index 3, then index 4, likewise. Okay. So let us, run a loop. For int I equal to 1, I less than n, I plus plus. Okay. Code by user input. Chalo yaar, le lo. I don't understand this part. Taking user input is nothing different, right? I will expect that you guys try those things, right? I can do it. I don't have a problem. But I would expect that you guys do it, right? Let's just ले लेते अब बना लिए. It's nothing, boss. It's basic. Take the size of the array input from the user, then make an array of size n. काम बस मेहनत बढ़ जाता है और कोई बात नहीं है. Okay. Then take inputs. No other way to take input, man. No other way. Okay. Cool. Taken inputs. Now what do I do? Now I want to write my insertion sort. Okay. Now what do? I start from index I equal to 1. Okay. What is the element that I want to insert? I equal to 1 hai. That means the element is ARR of I. So what do? I again start a loop. For int j is equal to I minus 1. Okay. J greater than equal to 0, j minus minus. And what do? If ARR of j, okay, is greater than ARR of j plus 1, then what should I do? I'll copy the code. At least that we can do, right? वो तो समझ में आएगा. Let's just copy this part, right? थोड़ा लिखना कम पड़ेगा. Two variables are declared n. Okay, sorry. You guys, can you just help me to format this? Let's just quickly format this. थोड़ा खराब हो गया formatting इसका. But I think everyone understands, right? Is it making sense? Will ever j go out of bounds? सोच के देखो, अपने आप से पूछो. Will j ever go out of bounds? Something bad has happened. Yeah, have we missed the brackets or what? पूरा लिख ही देना चाहिए था यार. Okay, yeah. Is it fine, guys? But instead of return here, we will write break. है ना? Looking fine? Same code, right? Same code. And outside this for loop, I can say print your array. Now I am showing you one other way of printing the array, right? You can also do like this. Arrays, okay, dot to string. So I can convert my array to string and print it, okay? So arrays dot to string, and then you give the name of the array. So this is a way in which you convert your array into a string and you print that string to the screen, okay? ये एक नया method बताया हूँ, arrays dot to string, okay? Let's try to run it and see. Okay, give me the size of the array. Let's take 5 elements, right? Let's take 5 elements and let us write elements 4, 8, 2, 6, anything, and 3. Okay, let's see. See, guys, 2, 3, 4, 6, 8. Is it sorted? Yes? Sorted? Hai? Anybody have any doubts in this code? Forget functions. Any doubts in this code? Any doubts in this code? Any doubts? If you remove the else part, nothing will happen, right? You will, break part agar remove karoge, or even if you remove this entire else part, no problem. You will just run the loop more number of times, right? Okay, cool. I converted the array to a string because I didn't want to write a for loop to print the array. I can print the string in one line itself, right? Okay, guys. So this was the basic code. Now I'll come to you guys. Are you clear with the concept, right? I'll just copy this link, disable chats. Okay. Abhi, I'll expect all of you to come here and just cast a poll. Okay. Now this time I have added one more option for you guys. Almost there, a little bit self-inspection needed. Okay. So ऐसा लगता है ना कि हाँ पूरा समझ में आ गया है. But एक बार I spend time on a piece of pen and paper, it will be, absolutely clear. पूरा ही clear हो जाएगा. So that I want to see. Just added this extra option, right? Just kindly go and, cast your polls here. So I can get a good picture of what is happening. Okay. Okay. So guys, you are becoming lazier day by day, guys. I am doing the hard work of speaking. You just have to go and click on a button. Yesterday we got 250 responses. Today 171. That is not done. Okay. So I will take your responses. The people who are not voting, I will just take a yes for you guys. So I see that approximately we have 94% people who are almost in the clear zone range, right? And once you do a dry run yourself, you will become absolutely clear, right? So the remaining 7%, take help from the people, right? Try to do a dry run, sit on for some more time, right? And you will get more clarity. Okay. Cool. I'll start the chats. Okay. Thank you, guys. Okay. So I'll ask all of you guys, okay, to please do a dry run on a piece of pen and paper. And even after that, you are unclear what is happening, DM me on Discord, DM your friends, or write, in the coding doubts channel. Okay. Yes, removing else. See, technically that will not, affect the time complexity. Worst case, it is still big O of n square, but the best case will get disturbed. Okay. And I will ask you all, once go here and try to understand what this is happening, right? Abhi मैं all time नहीं spend करूंगा, but I will share this link also, right? Try to see what is happening. You will understand. If you try to spend some time now, you will understand. Okay, guys, cool. So can we move ahead from insertion sort? Can we move ahead? Yes. Okay. Thank you. Okay. I think I'll disable chats. Right? I think it's for the benefit of all. Okay. Let's disable chats for the time being, right? Yeah, I'll take one more class on functions. ले लेंगे, ठीक है? Last में we have time for problem solving, right? So I have just disabled the chats. It's for everyone's convenience, right? I'll do a topic and then I can ask you for doubts. Does that work? Okay, you don't have a way of telling, but चलो ठीक है यार खोल देते हैं जो भी देख लेंगे. चलो ठीक है. Anyways, let's move on, right? Let's move on. Guys, please don't spam in the chats and just keep it limited, right? So that, people don't get lost. Will sort still remain adaptive? No, it will not remain adaptive. Okay, if you remove the else part, it will not remain adaptive. Okay. Yes, we have class tomorrow. Let's move forward. Okay, I think why students less in the class? See, every time we get drop-offs, right? Because people, kuch ka chhoot jata hai, then they want to, visit with the recordings and all these, right? Everyone is not able to, come up to the pace of the thing, right? So people prefer recordings also. And we don't have a problem, right? As long as you are studying. Okay. Okay. Let's disable chats. Chats. Okay. Now we'll come to a different, sorting algorithm, which is known as selection sort. Okay, selection sort. So let's get started with the concept of selection sort. Okay. So first of all, let me take an array. Okay. So first of all, I will help you guys with what is the basic idea behind selection sort. What is the intuition or what is the logic that basically selection sort employs, right? And why is the name selection sort? Okay. So I write here something for you all, right? So in selection sort, we select index. We select an index. Okay. In selection sort, we select an index. Okay. And find the correct element. ध्यान से सुनो. We select an index and find the correct element for that index. Okay. For that index. Okay. See, selection sort is very easy to follow and understand if you actually pay attention, right? So what do? I will be selecting indexes one by one and I will be bringing the correct elements to those indexes. Okay. So what do? First of all, I select this index. I start with index number 0. So I have selected this index. Now, do you guys agree? Do you guys agree that the correct element that will be coming at index number 0 is the smallest element in this entire space? Yes, yes. So see, I have selected this index, right? And what is the element? What is the correct element for this index? The smallest element in this entire array. So what do? I'm just telling first the basic intuition. 142 change करना है क्यों भाई इसमें कर लेते हैं ना. Now let us try to understand, right? So first of all, I have selected this index and what do I want to do? I want to search for the smallest element in this array. Let us say that somehow you select the smallest element. Yes, Jyotirmay, you can do for the big one also. I am telling by a small one. Okay. The visualizer that I will show you guys for selection sort, that employs a different technique. Okay. But I think it's better to be clear with both. Okay. So I have selected this. And what is the smallest element, guys? I iterate through this entire array. Okay. So first of all, I have selected my index. This is the index that I have selected. And then I will iterate through this entire array. Okay. Starting from index number I till the end. What is the smallest element? What is the smallest element? 1 is only there. So I know that yes, this element is at its correct position. Can I move further? Can I move further? Yes. So at index number 0, I have selected this index and I know that the correct element is at its, at index number 0 is containing the correct element. Now what should I do? Let's move forward. Now I select index number 1. Now I have selected index number 1. Okay. And now I want to search for the correct element that should come here. So guys, tell me, should I start searching from here or should I start searching from here? Badao. Where should I start searching from? Where should I start searching from? Okay, sorry. You don't have access to the chat. I just forgot that part. Huh. So I have selected this index and I want to find the correct element for this index. So from where should I start searching from? From index number I or I plus 1 or from 0? From where, guys? Can anybody help me? I should start searching from index I plus 1 or 0. See, guys, the long story short is you should start searching from index I itself, right? Because this can be the minimum element, right? I want to search for the minimum element in this part. Okay. So this also can be. So I start searching from here. Okay. I start searching. What is the minimum element in this part? The minimum element is 2. So what I will do? I will bring this 2 at index number 1. So what will happen? 1, 2, 4, 5, 3. So now index number 0 and 1 have their correct elements. Next, which index will I select? Next, I select index number 2. Next, I select index number 2. And now I want to search for the correct element that should come at index number 2. So I start searching from here till the end of the array. And what is the minimum element? What is the, see guys, do you agree? The element that will come at index number 2 is the minimum element in this part of the array, because 1 and 2 are already at their correct positions, right? Index number 0 and 1 have correct elements. So 3 is the smallest element. So I bring 3 to index number 2. Okay. Now, index number 0, 1 and 2 have correct elements. Now I select index number 3. I select index number 3 and search for the minimum element. What is the minimum element? 4. So I bring 4 here. Okay. Now tell me guys one small thing. After I have selected index number 0, 1, 2 and 3. Okay. Do I need to select this last index? Once I have made sure that index number 0, 1, 2, 3 all have correct elements, can I say automatically index number 4 will also have its correct elements? So what are we doing? If you have an array of size n, you have to select n minus 1 indexes, starting from index number 0 till index number n minus 2. Do you all agree? Do you all agree? You select indexes from 0 till index number n minus 2. So what is the thing that we are doing? What is the thing that we are doing? Okay. Now I'll explain to you the algorithm that we are doing. Very simple. Selection sort is one of the simplest to understand, right? So first step is what? In selection sort. In SS means in selection sort. I will find elements. I will find the correct elements. Okay. For index number 0, then 1, then 2, then 3, likewise till index number n minus 2. Do you agree? I will select indexes from 0 till n minus 2 and I will find the elements for these indexes. This is my first step. First is select the indexes. And what is the index that I'll be selecting? From index 0 till index number n minus 2. Boss, if you have an array of size n, first you select index 0, bring the correct element here. Then you select index 1, bring the correct element here. Then you select index 2, bring the correct element here. This is index number n minus 1 and this is index number n minus 2. Okay. Then you select index number n minus 2, bring the correct element here. Once all the correct elements are here, won't the last index automatically have the correct element? Batao? Boss, if from index 0 till index n minus 2, all elements are correct, then index number n minus 1 will automatically have the correct element. Yes? How many of you are understanding this part? How many of you are understanding? Yes? Okay. Cool. Acha, one small request. Guys, try to join in with your original names, right? When I see names like Death Note, Dream Abroad, how do I refer to you guys, right? So just use your original names. It is like little bit simple to refer to you guys if I want to ever talk to you, right? Okay. So yeah, what do we do? First of all, I select an index. Okay. So let's say this is your array. By n minus 2. Batata hu. We will see. Okay. Acha guys, first of all, my task is to select an index. Okay. First, I will select an index. Okay. I select index number 0. Then what I will have to do? What is step number 2? Yes, Tushar, it is opposite to bubble. Completely opposite to bubble. We will see. What is step number 2? Finding the minimum element. Finding minimum element for the selected index. Yes, correct. Find the minimum element for the selected index. Now let's say that you have selected this index 0. You have selected index 0 and you find that your minimum element is here. Okay. Let me call this index as min index. Okay. Min index is basically containing the index of the minimum element. Okay. So let's say you have selected index number 0. You iterated through the entire array and you tell boss the minimum element is present at this min index. Then what should I do? I should swap ARR of 0 with ARR of min index. Do you agree? When I swap these two elements, right, I will bring the minimum element at its correct position. Yes? Are you getting the point? Then the third point is swap. Yes? Okay. Let me give you an example. You will understand it better. Yes, give an example, right? Tell me some numbers. Some people were, talking of numbers, right? Can you give me numbers? I will try to explain selection sort in detail. Can you give me an array? Anyone? 8 5 5 9 2. Okay. 8 8 4 1 2 3. चलो ये ले लेते हैं यार. 8 8 4 1 2 3. Okay. Now, why can't we select random index? No, we can't, right? That is not how selection sort works, right? So we have taken this array 8 8 4 1 2 3. Okay. Now let us try to understand exactly what happens. I'll stop the chat for the time being, right? Let us try to understand. Okay. So what are the indexes? 0 1 2 3 4 5. Okay. And for more, visual understanding, let us draw a box also. Okay. So first of all, I select index. Okay. First of all, I select index. What index? I will select index number 0. So I is equal to 0. So मैं बोल रहा हूँ, boss, the value of I tells me what index have I selected. So first of all, I select index number 0. I select this index, right? Now what do I need to do, guys? I need to find the minimum element. Okay. So first of all, I assume I need to find the minimum element here, right? So मैं क्या करता हूँ? First of all, I assume I make a variable min index, and it is also pointing to I. It is also equal to I. So okay, so min index is pointing to this 8. Ki boss, the minimum element is also at index 0. Try to understand the algorithm. Okay. So मैं assume कर लिया हूँ boss कि the minimum element is also this 8. But can I conclude that this is the minimum element? No, na. I have to iterate over the entire array before I can conclude that this 8 is the minimum element. So what do? I start iterating through the array. Okay. So I start a pointer j from where I can start j from I plus 1. Now you will ask me, why don't I start j from I? Because I have already taken into account that this might be the minimum element. Min index is pointing to here. This can be the minimum element. Try to understand, right? So I start j from I plus 1. I start j from here. I check. I check like this. Is ARR of j less than ARR of min index? Can you help me, guys? Is ARR of j less than ARR of min index? Anybody? Chats have been activated. No, it's not. So what I will do? Just move forward, right? Just move forward. J moves forward. Okay. J moves forward. Okay. Next I compare. Is ARR of j less than ARR of min index? Is ARR of j less than ARR of min index? Yes, it is. So you know what I will do? I know that 4 is the new minimum. That should be coming here. But I will not swap now. Okay. You can swap, but I will not swap. What do is, I just update my min index. I just bring the boss, this is the new minimum element. So now the value of min index will be 2. Okay. Now, again, j moves forward. J comes here. Is ARR of j less than ARR of min index? Yes. So what should I do? I will again update my min index. Min index come to 3. This is the minimum element. Okay. J moves forward. Okay. Is ARR of j less than ARR of min index? No, it is not. So I will move j forward. Is ARR of j less than ARR of min index? No. Move j forward. Job done. Now, at the end of this entire loop, I know that min index is pointing to the minimum element. And what is the correct location for this element, guys? Can you help me? Can you help me? What is the correct location for this? I. Correct. So I will swap ARR of min index with ARR of I. So what will happen, guys? This one goes to index number 0. So see what happens. अच्छा guys, एक और काम कर ही लेते हैं. ठीक है? बाद में बताऊंगा स्टार क्यों लिया है. Okay. So now one goes at index number 0. Okay. And you have 8, 4, 8 star, 2 and 3. Okay. Now I say that one pass of selection sort has been performed. And after one pass, I can tell you, boss, index number 0 is containing the correct element. Do you agree? Yes. Now what do? I do a I plus plus. Now I will select index number 1. I select this. Okay. Then now I need to search for the minimum element. I need to search. So first of all, I assume ki boss, this might be the minimum element. So min index is also equal to 1. Ki boss, this can be the minimum element. Now, where do I start J from? Can anybody help me? Do I start J from here? Or do I start J from 4? From 1 or 4, where do I start? I start from 4, right? Because I've already considered 8 to be the minimum and this is already at its correct position, right? So I start J from I plus 1. I compare. Is ARR of J less than ARR of min index? Definitely yes, right? So this is the new minimum. See guys, you can swap. Okay, you can swap. But I won't be swapping, right? I will be updating my minimum index. So I bring my min index equal to J. Okay, this is the new minimum element. And then J moves forward. Okay. Is ARR of J lesser than ARR of min index? No. Move J forward. Is ARR of J lesser than ARR of min index? Is it? Is it? Yes. Yes, it is. So what I will do, I update the min index. So min index comes here. Okay. Then what will happen? J plus plus. Now, is ARR of J less than ARR of min index? No. Do a J plus plus. Now, I know that min index is pointing to the minimum element. And where should this 2 go? This should go at index number I. So I will swap ARR of I with ARR of min index. So what happens? 1, 2, 4, 8 star, 8. Okay? Making sense, guys? Now I have performed 2 passes of selection sort. Okay. No, it doesn't make any difference. It doesn't make any difference, Vinan. You can swap at the time being also. But the reason we don't swap is I will tell you a little bit later. मैं बताता हूँ, ठीक है? Okay. So 2 passes have been done and now index 0 and 1 are containing the correct elements. Now what index will I select, guys? Can anybody help me? I select index number, this one, index number 2. Okay. Assume this is the minimum element. Min index is here. Okay. Then what will happen? I start J from I plus 1. Is ARR of J lesser than ARR of min index? Definitely no. Move J forward. Is ARR of J less than ARR of min index? Definitely no. Move J forward. Is ARR of J lesser than ARR of min index? Yes, it is. So I will update my min index. Okay. And then when I move J forward, done searching the entire array. Now I know that this is the minimum element. So I will swap ARR of min index with ARR of I. Okay. Everyone is following till here? Yes? 1, 2, 3. 1, 2, 3. 8 star, 8, 4. Okay. Mukul, एक बार dry run करने का try करो pen and paper पे, right? I think I'm trying to go very slow and, you know, we'll try to, I can't spend more time. But yeah, एक बार एक काम करो, मेरे को DM करो, I can sit with you different. Okay. अलग से बैठ के बता सकता हूँ एक बार, if that helps, right? Okay. Okay. So now 3 passes of selection sort has been done and index 0, 1 and 2 are containing correct elements. Agreed? Now what index do I select? Next, I will select index number 0, 1, 2, 3. I equal to 3. Okay. Now I will again search for the minimum element. So first of all, I assume that this is the minimum element. So min index is equal to here. Okay. Now, what do? I start J from I plus 1. Okay. Because see guys, actually my search space was entire this. Okay. But why am I starting J from I plus 1? Can anybody help me? Can anybody tell me? My ideal search space was from index I till index number n minus 1. ये मेरा search space है. But why am I starting J from I plus 1? Because I have already assumed that the 8 star can be the minimum element. Min index is already pointing at I. Okay. Now J starts from here. Is the ARR of J lesser than ARR of min index? No. Move forward. Is the ARR of J lesser than ARR of min index? Yes. So I will update my min index. Min index comes here. Okay. Min index comes here. Now J moves forward. Job done. Now this is the minimum element. So swap ARR of min index with ARR of I. कर देते हैं. Okay. Now the value of I increases and now I will select this index. I select this index. Okay. Now what happens? I select this. Now what happens? I have assumed this is the minimum element. Min index is here. Okay. Now I start my J from here. Is this lesser than ARR of min index? No. Move J forward. Job done. Right. So what I will do? I will swap ARR of min index with ARR of I. So this 8 gets swapped with itself. Job done. Now I see I have performed 5 passes of selection sort. And can I say these indexes now have their correct elements? So the last index will automatically have its correct element. हो गया क्या? खत्म. Has the sorting technique finished? Yes, it is finished, right? And one thing that you all understand with this, look at my input. 8 star was before 8. And look at the output. 8 star is after 8. So is it stable? तो एक चीज तो पता चल गया guys. It is unstable. Everyone understands this? Example के साथ दिखा दिया, right? If I have to prove something is not stable, I just need one counter example. And I took an example in which the stability criteria got violated. So definitely selection sort is unstable. Okay? इंडेक्स 0 को मिनिमम पकड़ के पूरा एरे में मिनिमम सर्च करना है. मिनिमम मिलते ही इंडेक्स 0 को मिन से अपडेट करना है. आई राइट. Kind of correct, right? So first of all, you see, index I we select, we then search for the minimum element in this region, okay? And then we swap ARR of I with ARR of min index, okay? Can anybody help me with the time complexity? Can anybody help me with the time complexity? 8 और 8 repeat, क्या हो गया भाई? देखो कुछ नहीं. See, I had selected this index and I assumed that this is the minimum element, okay? This is the minimum element. Now what do? I start J from here. Is ARR of J lesser than ARR of min index? No. Move forward. Array finished. Now what do? I swap ARR of min index with ARR of I. So this 8 gets swapped with itself. Job done. Okay. Now I just want that I should come till here. All these indexes are done. This last index also correct, contains the correct element. Okay. So the time complexity, if you realize very carefully, what am I doing? Okay, I think the slides, it's n square. It's n square. Right? 8 star is not disturbed by it. How unstable? Vedant, what is stability? I asked you this question. What is stability? What is stability? What does stability mean? Help me. What does stability mean? The relative ordering of the same element should not be disturbed. If you look at my input, if you look at the input, right? Where was 8 star coming? 8 star was coming before 8. Look at the output. Where has 8 star gone? After 8. Definitely unstable. The relative ordering has been disturbed in this sorting technique. Okay. Okay. Now let's come here. Okay. Now, why do I say that, it is n square time complexity? Why do I say this? See, we don't even need to look at the code. We don't even, yes, I will definitely, guys. See, we don't even need to look at the code to understand the time complexity. What are we doing? I select this index, run through the entire array. Select this index, run through the entire array. Select this index, run through the entire array. Is it not giving you an n square feel? For every index, you iterate through the entire array. So for n indexes, you will be iterating through the array. So n square, right? So the time complexity is big O of n square. But once we write the code, it will become even more clear. And what is space complexity, Manish? Space complexity is big O of 1. Have you used any extra space? No, only basic variables and swapping. So it is big O of 1. Okay. Now, the next question is, I understand it's big O of n square time complexity. Code ke through dekhenge. And is it stable? No, it is not stable. Did you guys understand why it is not stable? Because at the end of the day, you are swapping. Okay, you are swapping. Okay, and in swapping, the relative ordering can get disturbed. Take a very, very simple example, right? Take a very, very simple example. Ruko, sochne do. What can I give you? Just a very small example. Let's take like this. Simple example, right? When I select this index, this 2 will come here, and what will happen, guys? समझ आ रहा है क्या होगा? This 2 will come here and 8 star will go after this 8. So definitely, guys, it is not stable. Definitely not stable, right? Is it adaptive or not? Adaptive है या नहीं है? Can anybody help me? Can anybody help me? Is it adaptive? सोच के देखो, guys. Take a sorted array. Very, very simple task, right? Take a sorted array. What are you doing? I select this index. Okay. I iterate through the entire array, and I see that, boss, this was only the correct element. So I swap 1 with itself. Then I choose this index. I assume this is the minimum element. Okay. Then I again iterate through the entire array, and I see this is the minimum only. So I swap this with itself. So it is not adaptive. It is not adaptive, guys. Not adaptive. Definitely not adaptive. Definitely not adaptive. Why? Because see na guys, for every index, you don't know whether it is the correct element there. Now you cannot make it adaptive like this, right? You cannot make it adaptive in a simple fashion, right? You, for every index, you have to search in the array in order to make sure that that is only the smallest element. So definitely it is not, you know, adaptive. Do you get this idea why it is not adaptive? कितने को समझ में आ रहा है why it is not adaptive? Yes? No. Okay. Okay. Let me write the code. Then it will become more clear, right? Then it will become more clear. Okay. So guys, first of all, what were we doing in code? We were first of all selecting an index. And from where till where we started selecting indexes? We started from index 0. Okay. And went till index number n minus 2 inclusive. Do you agree? First we selected index 0, then index 1, then index 2. Enough? Then index 3 till index number n minus 2. So let's run. For int I equal to 0, can I write I less than n? No, yn. I don't need to go. Till I less than n minus 1, I plus plus. Can I say this thing? Yes, can I say this thing, guys? Can I say this thing? I start, so first of all, index 0, I'll search for the correct element for there. Then index 1, then index 2, then index 3, till index number n minus 2. Do you all agree? First you will select index 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, till index number n minus 2. Okay, because once you get the correct element for index n minus 2, now automatically index number n minus 1 will have the correct element. Okay, so I will go all the way from 0 till index number n minus 2 inclusive. Now what do I do, guys? I am searching for the correct element that should come at index number I. Okay, what should I do? What was I first doing? I have to initialize a variable min index. I will initialize a variable min index. And what should be its value? Can anybody help me? अगर तुम लोग लॉजिक समझो, you will be able to tell me. Correct कुंदन, correct death note. नाम चेंज कर लेना next time यार, है ना? So min index equal to I. So first of all, I have assumed that the minimum element is occurring at index number I only. But can I definitively tell you that the minimum element is at index I only? No. You have to scan the entire array before you can conclude what is the minimum element. Okay. So what should I do? I will start searching in the array. I will start iterating over the array. From which index? From index number I plus 1. I will start from index number I plus 1. And till where should I go, guys? Till where? Till where should j go? J less than what? What should I write here? What should I write? N, right? J should go till the entire end, right? J plus plus. And what do? I see if ARR of j is lesser than ARR of min index, what should I do, guys? Can you help me? If ARR of j is lesser than ARR of min index, correct, guys? No, I am not swapping. I am just updating the min index. Ki min index is equal to j. So I have updated my min index. Ki boss, ARR of j is lesser than ARR of min index. So this is the new minimum. So I will bring the min index pointer at j. Okay. Do you all agree with this part? Yes. Acha, guys. Now tell me, outside this for loop, acha, if ARR of j was greater, then you didn't do anything, right? You just did a j plus plus. So outside this for loop, can I say you have searched and iterated over the entire array? Can I say outside this for loop, you have iterated over the entire array on the right hand side, right? So what should I do? I should swap what? ARR of I with ARR of min index. Do you all agree with me? Yes? Do you all agree? सोच के देखो, guys, what are we doing? See, if you are taking I less than n, that is also fine, guys. That is also fine. But you don't want I less than n, right? Try to understand. अगर 5 लोकेशन है आपके पास, तो पहले मैं इसको सेलेक्ट करूंगा, फिर इसको, फिर इसको, फिर इसको. एक बार इन चारों पे सही एलिमेंट आ गया ना, तो पांचवा ऑटोमेटिकली डन है. Try to understand. This is index number n minus 2. This is index n minus 1. Try to understand. Okay. How many of you understand the code? कितने लोगों को समझ में आ रहा है? I is basically the index. मैंने select किया है index. Then I say, let us assume that the minimum element is at index I. Then I start j from I plus 1 and go till the end of the array searching for the new minimum element. And I see that if ARR of j is lesser than ARR of min index, that means I have got the new minimum. So I will update my min index. I will bring min index to j. See, let's take an example, right? सोचना guys, can you make it adaptive? Flag लगा के बताओ मेरे को कैसे करोगे, right? I am interested in hearing your thoughts for sure. Okay, let's see this. Let's see this. Please listen here. Okay, see here. Okay, so first for int I is equal to 0. I is here. I have assumed that this is the minimum index. This is the minimum element. Okay. Now what do? J starts from I plus 1. So J starts from here. And see guys, why will J go till the end? You will get your answer here. The minimum element can be present at the last, right? I don't know where is the minimum element present. You have to iterate through the entire array. So J will go till the end, right? So is ARR of J less than ARR of min index? No. Move J forward. Is ARR of J less than, oh, sorry. ARR of J was lesser than ARR of min index. So what do? I bring min index is equal to J. So min index comes here. Then I do a J plus plus. J comes here. Is ARR of J less than ARR of min index? Yes. I update min index. Min index equal to J. Then I move J forward. Is ARR of J lesser than ARR of min index? No. Just move J forward. Is ARR of J lesser than ARR of min index? Yes. Update min index. So now min index is here. Then when I do a J plus plus, this loop terminates. So outside this for loop, min index is pointing to the minimum element. And I know that the correct place for this element is index number I. So I do a swapping of ARR of I with ARR of min index. And then I will move I forward and select the next index. Is it making sense? Yes? I don't know if there is an inbuilt function. I don't know. Right? Why J less than N? अरे भैया बताया तो अभी. J should come till the end na. You are searching for the minimum element na. So you should iterate through the entire array. So J should come till the last index na. That is why J less than N. Simple. है ना? Okay. Now, if you look at the code, are you getting an idea that the time complexity is big O of N square? See, for I equal to 0, how many times the inner loop will run? Let's do the fundamental computations, right? Let's do fundamental computations. Fundamental, ठीक है? Is every nested loop? Not really, I would say. मैं बताता हूँ, आज ही बताऊंगा, ठीक है? Okay. Guys, for I equal to 0, how many times the inner loop runs? How many operations are performed? Worst case, we are talking of worst case. For I equal to 0, how many operations? N minus 1, right? Because you will iterate, देखो ना, logical है. For I equal to 0, you will iterate through this segment of the array. So N minus 1 elements you will iterate. So for I equal to 0, you iterate and this loop runs for N minus 1 times. Similarly, for I equal to 1, you will iterate in this part. So you iterate for N minus 2 times. For I equal to 2, you iterate for N minus 3 times. And when you select this second last index, you will just iterate once. You will just see the last element. Okay. Are you getting the feel, guys? It is 1. So if I add up the number of operations is 1 plus 2 plus 3 plus 4 up till N minus 1. So again, it is kind of N into N minus 1 by 2, which is N square. Okay. So how many comparisons are done? N square, N into N minus 1 by 2 comparisons are done. So if I want to tell you the worst case time complexity of selection sort, what is it? It is big O of N into N minus 1 by 2 or big O of N square. How many comparisons? Big O of N square. What is the space complexity? Big O of 1. Okay. Is it stable? No, it is not stable. Is it adaptive? Now you will only tell me, is it adaptive? Look at the code. Look at the code. Do you think it is adaptive? No, it is not adaptive, right? Because even if it is sorted, you will run this loop entirely. The min index value will not change and you will swap ARR of I with itself only. Okay. But you still have to run this entire loop. Na? So definitely it is not adaptive. Okay. Making sense, guys? How many of you are clear? Yes, guys. Okay. If I use J less than N, क्या पूछ रहे हो? एक second. कहाँ गया भाई? If we use I less than N, then I plus 1 goes out of bound. But then the loop will only not run, na Mehran. If I is less than n, right? And you start j equal to I plus 1, j less than n, na. So this loop will not run. The loop will not only run. Okay? Cool. So adaptive, bataya to. Adaptive means that if you give it a sorted input, okay, if you give it a sorted input, is it taking less number of time? No, it is not taking, right? Even for a sorted input, the time complexity of selection sort will be big O of n square. Okay. Cool, guys. Can we go to the visualizer? Can we go to the visualizer? Yes? Okay, cool. And then we'll quickly code it up. What's the time? Okay, great. We have. Ja raha hu. Visualization, then code, right? What's the use if it's unstable and not adaptive? Boss, if you want to appreciate a better algorithm, you need a worst algorithm, right? मतलब you only realize what is good when you have encountered the worst, right? एक ऐसा dialogue रहता है ना, you never know what is good until you have faced the bad things. That is why यार, मतलब सारे type के algorithm है. What is the best complexity? The best also is n square, right? Even if you give it a sorted input, it is taking n square time. So the best case runtime is also big O of n square. Okay. Number of swappings in the worst case. Can you help? Can anybody tell me what is the number of swappings in the worst case? Good question. Thank you. You have raised this. How many swappings are happening in the worst case? Guys, there are only n swappings. Now, this is another beautiful thing of selection sorts. Selection sort has big O of n number of swappings because when are you swapping? You are swapping once outside this for loop. So every time this loop runs, you are just swapping once. Now, at the end of the pass, you are swapping. Okay. So the number of swaps is big O of n. So guys, do you get one stark difference between bubble insertion and selection sort? Selection sort minimizes on the number of swap operations. See, in bubble sort, you had n into n minus 1 by 2. Yes, it is n minus 1. Correct. Big O of n to rough bata diya. In bubble sort, you had approximately n square comparisons or n square swaps in the worst case. In insertion sort also, we had n square swaps in the worst case. But in selection sort, what are we doing? See, you select an index, you iterate through the entire array, and then you do just one swap. So in every pass, you are doing one swap. So n minus 1 passes, so you do n minus 1 swaps. So in selection sort, you have minimized the number of swaps. Do you all agree? Yes? So if somebody tells you, boss, swap operation is very costly. Okay. Yes, n minus 1 swaps in the worst case. Yes. So if somebody comes and tells you that, hey, Adarsh, you know what? A swap operation is very costly. It is very expensive. मेरे को swap कम से कम करना है sorting में. What algorithm will you suggest me? I am asking you, hey, I want to minimize my swap operations. What algorithm will you suggest me? Selection sort, right? So that is a characteristic trait of selection sort. And one other important thing that I want to, it will be uploaded, man. It will get uploaded. And the other thing is, do you agree? In every pass of selection sort, the lightest element is coming and settling at its correct location. Soch ke dekho, guys. Soch ke dekho, what are we doing? In every pass of selection sort, the lightest element came and settled at the bottom. So the intermediate results of selection sort has meaning or has utility. So if somebody asks you, second smallest element, what will you do? Just perform 2 passes of selection sort. Okay. Just run selection sort for index 0 and index 1. You will get the 2 smallest elements here. Are you getting it? Yes. See, there is nothing like one is better than other, right? Selection sort ka good point is it is minimizing on swaps. Insertion sort good point was it is adaptive. So every sorting algorithm has its, own run times. Okay, just give me 1 sec, guys. I'm getting a call. Yeah, I'll give you a break once we code this up, right? Intermediate means after one pass, right? Intermediate means after 1 pass or 2 passes, after 3 passes, right? Are the intermediate steps making sense? How to stop after 2 passes? Okay, I'll ask you this question. Okay. So first is, if everyone is clear, what do you want first? Visualizer or code? Visualizer or code? बताया तो good example of adaptive. I told the insertion sort. Yes, that's a good example of adaptive. Okay, let's come. Visualizer ही देख लेते हैं चलो. But now in Hacker Earth, the visualizer is made in a different sense, right? What we were doing, we were bringing the lightest element to the front now. Here they are getting the heaviest element to the back. Okay, तो थोड़ा सा अलग है, but the logic is almost the same, right? देखो, अब ये लोग क्या करेंगे देखना. For every pass, they are moving the heaviest element to the back. Okay, they are implementing a kind of a reverse selection sort, close to bubble sort, but not exactly bubble sort, right? Because in bubble sort, you were comparing adjacent elements, but here we don't compare adjacent elements, right? So what are they doing? Now see, they start pass 0. So see, what were we doing? We were initializing the min index. They are initializing the big index. उल्टा है, जो आपने किया है ना उसका उल्टा है. Now what will happen? See, हाँ, see, they will compare 200 with 79. ARR of J with ARR of big index. Is it greater? No. Move forward. Is 438 greater? Move forward. Greater नहीं है, greater नहीं है, greater नहीं है. Is 851 greater than ARR of big index? No. Move forward. Is 200 greater? No. One pass has been done and this is the maximum element. So where should it come, guys? This should come at index number 7. So now you will see that they are swapping the elements at index number 7 and index number 0. देखो. Do you understand? We were doing the same thing, but we are bringing elements to the front and they have sent elements to the back. Is it making sense? Yes. Next, what will happen? Now see. Now see. Next, I will select what? Next, we will select index number. See, they are basically doing it in a different format, right? They now see. They have basically initialized the big index always here. They are doing it in a. एक सेकंड यार, कौन आ गया? Dinesh, I think you just have to use the chats a little bit, more thing, right? Yeah, they are basically, ये लोग क्या कर रहे हैं ना? They are finding the heaviest element always. They are finding the heaviest element in the space and they are pushing it to the back. Okay. What we were doing is we were finding the lightest element in the space and we were pushing it to the front. Okay. So ये लोग क्या कर रहे हैं? See, try to understand, guys, what they are doing. They are getting the heaviest element in this space and pushing it to the back. Then again, they will get the heaviest element from this space, push it to the back. Are you getting it? Okay. Yeah. So let's see. Again, they will find the biggest element. Okay. Is 200 greater than 200? No. Is 438 greater? Yes. So they will update big index. Dekho. Is 65 greater? No. 77 greater? No. 72 greater? No. Is 851 greater? Yes. So they will update. And 851 is swapped with itself. Okay. At its correct location. Right. Next, what we will do? Now they will find the biggest element. Now they will find the biggest element in this space. Okay. And they will bring it here. Dekho. At the start, we should swap. No. Why? They are initializing this as big index. Now they will say, is there any other bigger element in this part? See, is 200 greater? No, it is not greater. Is 438 greater? Yes, they will update the big index. Okay. Now, is 65 greater? No. 77 greater? No. 72 greater? No. Pass completed. Now they will swap this 72 with 438. Dekho. Okay, na? समझ आ रहा है, guys, what is happening? They are doing the reverse of what we had done. Now they will look in index 0 to 4 and find the maximum element. Dekho. Assumed that this is the maximum and they will search. Okay. Nahi mila? Swap. See? Getting it? Next, again, they will first, है ना? 77. Then they will see that yes, 200 is bigger. So 200 gets updated. Then 72 के साथ compare, 65 के साथ compare. Then you do a swap. Okay. So I'm not going till the end, but is it making sense, guys? Yes. Reverse of what we have done. Okay. Cool. So let's quickly go to the code. Yeah, they are doing differently. We have done differently, but the essence is the same, right? The essence is the same. Okay. But most commonly, what code we have written, right? What logic we have done, there you will see, right? Ki most of the people write selection sort like this. Actually, this visualizer was doing it in the reverse fashion, but मेरे को लगा समझ में तो आ ही जाएगा अपने लोग को main thing. So I thought, yeah, let's show this only. Okay. So now let us write selection sort, right? Now, let me write it via function, a very basic function, right? And let's see if you guys understand via functions. Okay. एक basic function लिखूंगा सिर्फ, right? So what I am writing is public, yeah, it is doing in descending order. Correct, Amit. Public static. Acha. Now, guys, tell me one thing. if I am making changes inside an array, ऐसा सोचो, चलो थोड़ा सा इसको डिस्कस कर लेते हैं डिटेल में. If I am making changes in the array, let's say you receive a copy of the reference, and if you make changes inside the array, then will it be visible to the main method? सोच के बताओ पहले मेरे को. You have sent a copy of the reference. You make changes. Boss, it will be visible in the main, right? Because the object is one only, right? It is visible in the main also. You have the reference to this object in the main also. Okay. So what should be my return type? Void. Because I am making changes in the array in place. Void, return type void. Okay. Now what I'll do is, let us call it as selection sort. Okay. Also guys, one small term I forgot to tell you. All the sorting techniques that we have discussed till now, which are big O of one time complex, space complexity, right? We call them as in place sorting techniques. लिख देता हूँ यहाँ पे, note down कर लो. We call them as in place sorting techniques. In place. Why in place? Because they don't use any extra place. They are making changes in the array itself. In place. Extra place नहीं दे रहे, okay? So these are in place sorting techniques. Okay. Now, selection sort. What will it get? It will get the reference of an array object int ARR. Reference मिल गया. Now let us start selection sort. Let us start writing the code for selection sort. Very simple. Let us start for int. Acha, first of all, let's determine the size of the array. In place is nothing. In place is basically the algorithms. Okay. The algorithms which have constant space complexity. Okay. We call them as in place sorting algorithms. In place. You are not taking any extra place. Okay. क्या लिखे हो? Only the array reflects changes main in. N won't be present in main, right? N won't be present in main. The array reference is there, right? So yeah. In place ka opposite, you are taking extra space. Okay. Auxiliary space on top of that. Okay. So int n is equal to arr.length. I think the pace today has been fine. So that, I wanted to take questions on time and space also. So that's why. Enough. So int n is equal to arr.length. Now what do I do? Achha guys, before even I take, how many of you have diligently done a reading of the articles that I shared? कितने लोग सही में पढ़े हैं वो? इस पे भी poll कर लेना चाहिए. But I don't want to get disappointed, so I won't do a poll on this. Okay, cool. चलो ठीक है. Okay, I appreciate that you have at least started or tried, right? Okay, cool, no issues. ठीक है. So int n is equal to arr.length. Now what do? I started reading, right? For int I is equal to 0, I less than where? Till where should I go? Till where should I go? Anybody help me? Till index number n minus 2. If I talk inclusive till index number n minus 2, so I will do I less than n minus 1. So automatically it's ensured that I is coming till index number n minus 2, I plus plus. Okay. Now what? I have selected index I. That is, what is the meaning of I? I have selected index number I. Okay. Achha. Now what do? Now I first of all assume that the minimum element is present at this index I itself. So int min index is equal to I. Now what will happen? Yeah, we are completing 3 sorting techniques today. Okay. From tomorrow we'll start with recursion. Okay. 2 days for recursion, then 2 sorting techniques. Then we will solve variety of problems on sorting. Okay. And meanwhile, in the doubt sessions, they will start taking up questions on sorting. Okay. Okay. Did I share the plan with you? नहीं किया, मैं भूल गया. ठीक है. Anyways, so where will J starts from? What is my search space from index I plus 1 till the last index? So J starts from index number I plus 1. J will go till the last index, J plus plus. Okay. And what do I check? If ARR of J, if the element that J is standing on, that is lesser than, ARR of min index. Okay. If that is lesser than the current minimum, then I need to update my minimum because I have got a new minimum. So what I will say, boss, the new minimum element is occurring at index J. So I will update my min index is equal to J. Kar diya update? Okay. Now what will happen? Done. Now after this entire for loop completes, what do I say? Boss, the minimum element is present at min index. Okay. And where should it go? It should be present at index number I. The index I have selected. So what should I do? I should swap ARR of min index with ARR of IE. So let's swap. What is the swapping logic? Int x is equal to, let's say, ARR of min index, take a backup. Okay. Then what do I do? What do I do? ARR of min index is equal to ARR of I. Okay. Then ARR of I is equal to, kya karu? What should I write? Can anybody help me? X. Great. Time ho gaya. Surprise. Today we have class till 11. Okay. अभी problems discuss करना है थोड़ा time and space का, है ना? Okay. So have we done a swapping? And after swapping, can I tell you the pass number I has been done? हाँ, break दे दूंगा, 5 मिनट break दे दूंगा, for sure. Okay. Can I say the pass has been done? अच्छा guys, if I ask you, can you print the status of the array after pass? See, I have performed the pass, right? Can I print the array now? I want to see the intermediate results, right? So can I write here? I'm just making a string of the array and printing it, right? So I want to see what has happened to the array after this pass, right? थोड़ा सा और neat करते हैं, okay? After pass number I, okay? सही है? Zero based pass calculate कर रहे हैं हम लोग, ठीक है? So after completing this pass, I am printing what is my array looking like, right? हो गया? चलो. Now, guys, see, this is the very basic function that I have written. Now, guys, tell me, when this function terminates, you have made changes in your array object. तो क्या कुछ return करना है? Return type void ही रहने दो. No problem, right? You can write a return outside this for loop if you want. You can even skip it. I don't care. I don't care. Acha guys, somebody was asking, if I want to run selection sort only 2 times, what should I do? Where should I do the changes if I just want to run selection sort 2 times? Only 2 passes. यहाँ पे change करने से हो जाएगा काम. Okay. So now you get how do you get control over how many times you perform selection sort. That's it. Okay. Now I have a function which performs selection sort of an array. Okay. Now let's make an array here. Int ARR is equal to not taking user inputs. Okay. 8, 7, 3, 10, 8, 9. Okay. These are the array elements. Now guys, try to understand. I want to sort this array. So there is already a function. Ki boss, this is a black box which will take the reference of the array object and it will sort it. So what I will do? I call this function, write the name of the function within brackets, write the reference name. What is the name of the array? ARR. And this function is not returning anything. So I don't need to capture it in any variable. Job done. And after this, I will print boss array is sorted. Agreed, guys? Everyone able to follow? Yes? Yes. See, I am not writing min index equal to ARR of j because I want to update the index so that at the end I can swap. If I store the value now, how will I swap? For swapping, I need to know now where is that index, where is that value present? Index चाहिए मेरे को. ठीक है? Why not returning? You can write a return here if you want, right? लग सकते हो, कोई दिक्कत नहीं है. Okay. Now let's try to run it and see. You will understand. अच्छा guys. अच्छा guys, can you help me? How should your array look after pass number 0? How should your array look after pass number 0? तो draw करते हैं ना, तो अपने को समझ पाएंगे कि if is properly my functions running or not, right? This is the array. Okay. Return is nothing, boss. Your function terminates. You can write a return. Okay. 873 10 8 9. Can anybody help me? What happens after pass number 0? Can I say after pass number 0, my array should look like this? Everyone agrees? This is how my array should look like after pass number 0. Huh? Now what happens after pass number 1? Pass number 1, no changes. Do you agree? Pass number 1, no changes. Everyone agrees? Pass number 1, no changes. Yes. At the end of pass number 2, what will happen, guys? Again, no changes. Everyone agrees? मानते हो क्या? भाई साथ साथ बताते रहो. Yes. After pass number 3, what will happen? Can anybody help me? 3 7 8 8. 10, 9. Everyone agrees? Yes, 10, 9. What happens after pass number 4? 3, 7, 8, 8, 9, 10. Okay? Array sorted? इतना ही चाहिए ना 5 I wait. I think we'll need one more pass, right? Just 1 second. I think we may. So for index 0 we did. Here it came. Index 1. Okay. Index 2. Then we did for index 3. We did for index number 4. Did we miss an element somewhere? कुछ मिस हुआ क्या? I missed it. But yeah, let us try to run it. पहले run ही कर लेते हैं ना. Let's clean up. Anyways, अच्छा क्या problem हुआ इसको? अच्छा, it is telling, boss, I don't know what is arrays. Can you tell me a solution? Somebody has already written this code inside the arrays package. Inside the arrays class, there is a method toString. But my compiler does not know what is arrays. What should I do? Import. So import java.util.star. Okay. Arrays भी कर सकते हो, star भी कर सकते हो. Let us try to run it. Okay, let's try. See, after pass number 0, the element 3 came at the front. Correct? That is what we were expecting. एक बार फिर से कर लेते हैं यार, इधर ही अपने साथ है ना. Let us see. See, after pass number 0, you had 8, 7, 3, 10, 8, 9, right? So after the first pass, I expect this 3 to come, right? So 3, 7, 8, 10, 8, 9. देखो 3, 7, 8, 10, 8, 9. This is correct. Now what will happen at the end of pass number 1? This will remain as it is. See, 3, 7, 8, 10, 8, 9. No changes, right? At the end of pass number 2, again no change. 3, 7, 8, 10, 8, 9. Now at the end of pass number 3, what will happen? See, this 8 and 10 will get swapped, right? Dekh lo, 3, 7, 8, 8, 10, 9. Then what will happen at the end of pass number 4? This 9 and 10 will get swapped. Okay, array sort? See, array sorted. So you had basically an array of size 6. So you needed 5 passes. Pass number 0, 1, 2, 3, 4. 5 passes have been performed. Is everyone able to follow? Now let me open up the poll, right? Let me open up the poll once again. Same question, same options, copy link, disable chat. Ready. Yes, guys. And now the break of 5 minutes starts for you guys, okay? Break of 5 minutes also start. We will again start at 10:15. Okay. Kindly cast in your votes. Okay, it's overall thing I want to see. For selection sort, right? Okay. So for selection sort, it's 50-50. ऐसा क्या था भाई? Insertion समझ में आ गया. Selection में problem. Selection is simple, right? Okay. So the almost there people, the people who are almost there, can I expect you will spend some time yourself and you will able to grasp the concept? You almost there वही है कि आपको समझ आ गया है, बस थोड़ा सा एक बार सेल्फ मतलब चाहिए कि हाँ एक बार खुद से कर ले तो 100% हो जाएगा. Is this category that only? Please vote like that. If you are like this, नहीं मेरे को नहीं आया समझ में, go for no. If you feel yes, थोड़ा सा ही है मैं खुद से कर सकता हूँ, then only go for this category. Okay, cool. So I think again you guys are lazy, but yeah. See, any day guys, self study will be needed. See, what did I tell you for the first day? Only studying and attending the lectures is not sufficient. You will need to put in efforts yourself after the lecture. Then only you will be able to grasp concepts. अब भाई ऐसा थोड़ी है कि we all are geniuses. मैं तो अपने आप को नहीं मानता genius. And I am pretty sure most of us are not, right? We need time to process things. अगर सब कुछ एक बार में समझ में आ गया भाई भगवान बन जाओगे, right? So that is not possible. So you have to spend time for sure. Okay? निकालना होगा रामानुज. You have to take out time. The journey will not be easy, but it will be worth it, right? Okay. So everyone clear with this? Yes. Okay. At 10:15 we start. Okay. At 10:15 we start. Okay. I'll take some questions from time and space complexity. If you want to return an array, what do we have to do? If you want to return the reference of an array, you have to write the return type as check it out, right? I haven't personally done this, but yeah, यहाँ पे int bracket open bracket close लिखना and see we're trying to return the reference of an array. Okay, let's try this. मैं पता नहीं मतलब कोई फायदा नहीं है, but let's try this. This is checking it out. I am not sure, right? Okay, I'm just thinking logically. After making changes, return ARR. No use of doing this, but yeah, if you want, you can check. I am not sure. Either capture it in ARR once again. Okay, let's run. मेरे को तो यही दिमाग में आ रहा है, and seems like it works, right? But you don't really need of doing this thing, right? Yeah, I'll disable chats. Chat से बहुत लोग परेशान हो गए, right? Okay. Mamta, if logic is not clear and that thing, right? Sorry, logic is clear, but you are unable to write code, right? So see, that will come with practice. See, the conversion of logic to code, that actually comes with practice. आपको practice करना पड़ेगा. You have to be clear with what. If you understand the meaning of the loops, now you will understand why I am doing what we are doing, right? It's very important to understand the physical meaning of the loops. रटो मत कभी भी, right? The first time when I studied now, in 11 and 12, right? I just memorized the codes. I didn't understand it. But then later when I understood what was happening now, then I never forgot it the second time. I never had to look at the codes once again. Okay. So just focus on clarity and logic building. Okay. Conversion to code will take some time, but you will definitely get a hang of it. But please ratna mat. Don't do the mistake that I did in 11 and 12. I got a lot of time after that to recover. But at your stage, you don't have that time to recover if you don't understand, right? So जो समझ रहे हो अच्छे से समझो, नहीं समझ में आ रहा है dump कर दो, but don't memorize things, right? That won't help in the long run. And dump कर दो मतलब take help and try to do it, right? Put in your best efforts. Okay. Okay. 3 minutes. I also deserve a break, so I think I'll drink some water. Okay. We'll start sharp at 10:15. Okay, 10:15 to 11. 45 minutes. I will take some questions from time and space complexity. Okay, cool guys. Thank you. And yeah, guys, like one thing I'll share with you all, with hard work, na, anything is possible. At least I have experienced it firsthand, right? So I didn't rate myself very good in coding. मैं अभी भी अपने आप को नहीं उतना अच्छा रेट करूंगा कि no, I can't solve code forces division 1 division 2 नहीं होता है. But yeah, interview level I can solve now, right? But the thing was that when I first started ना, मेरे को भी कुछ नहीं आता था. Zero knowledge, right? But the thing is ना, consistency is a very important key in coding, right? If you are consistent, if you spend time writing code daily, it becomes a habit. फिर जिस दिन code नहीं लिखोगे ना, you will find something is missing. And once you inculcate that habit ना, then the graph of your rising, it's very steep. Like I have experienced it personally, and I am pretty sure that if you try it, right, just try to stay consistent. ऐसा मत see, there can be cheat days. I agree. Every day you will not, like to study. If you have a cheat day, do less study. But at least try to write code daily. Try to solve one question daily, at least, right, on your cheat days. Don't ऐसा मत करना कि दिन पूरा खराब कर दिया and no code you have written. That won't help. Okay. Cool. So I have enabled the chats once again. Okay. Okay. Cool, guys. So let's get started. Okay. Yeah. I don't know if like I'll just share an anecdote, right? So I just went to drink water and mom being mom, right? So 1 minute का break में आप खाना खा सकते हो क्या? है ना? So I told no, I can't eat dinner in 1 minute for sure. 5 minute का break में नहीं खाया जाता है. But yeah. Where do I work? I work at Nutanix. Okay. Cool guys. Okay. So one small thing, right? One small thing. So we have an inbuilt sorting technique. Okay, we have an inbuilt sorting technique. Okay, we have an inbuilt sorting technique. Arrays dot sort. Arrays dot sort. Okay, and you write the name of the array. It will sort this array for you. Okay, you have to import the arrays class. So import java.util.star, and you can sort an array using this arrays dot sort. Okay. ठीक है, take time, take 1 hour, no problem. You have time at this point of time, right? Cool. Okay, so what I'm telling you, acha, and in 90% of the cases, guys, 90% of the cases, whenever you want to do a sorting, okay, whenever you want to do a sorting, and somebody is not standing on your head with a knife and telling you to write your own sorting, or you don't want to, and implement, ऐसा case है कि मेरे को बीच में break करना है, then to you write your own sorting. But in 99% of the cases, if I want to sort something now, you will use the inbuilt sorting technique. Inbuilt sorting technique. How do you use that? Simple. देखो अब तुम लोग बोलोगे यार इतना क्यों पढ़ाया, जरूरी था. But now I will give you a shortcut also. Okay. So 7, 4, 8, 9, 10. बताता हूँ time complexity. ठीक है. And what I will do? Arrays dot sort ARR. My array will be sorted. And now if I print my array, I will convert it into string. Arrays dot toString ARR. You will see that yes, the array has become sorted. And you know one thing, you might think that this might be of a bad time complexity, right? But I will tell you, the inbuilt sort technique runs in n log n. Okay, the inbuilt sort technique runs in n log n. And can you tell me which one is better? Big O of n square or big O of n log n? Which one is better? Which one is better? This is bad, right? Because if you look at the graph, n square will grow at a much faster rate as compared to n log n. So n log n is better. So boss jo inbuilt hai, that is better also than what you write. So why do you want to write yourself, right? So it is like a very tricky thing, but yeah, you should definitely know. How do you sort it in descending order? Good question. Google up, right? Google up. Okay. Okay, cool guys. So now we come here. Okay. Now let's come to our time and space complexity. How to sort 2D array? So if you want to sort a 2D array, either you convert your 2D into a 1D, or you sort row wise, or you sort column wise. Okay, something like that. Okay. Yes, we will also be writing an n log n algorithm. Merge sort is n log n. Okay. Cool guys. Now let's focus, right? So I'm hoping you all have come prepared with at least the basic reading of the articles, so that you understand what is going on in the class, right? So first of all, I want you guys to rate. Okay, मैं थोड़ा सा ऐसे ही problem solving ही कराऊंगा. Okay. Can you rate these functions for me? If somebody asks you, boss, I have these 3 algorithms. Can you rate them? Can you rate them? Do you all agree? And see, guys, I'm not drawing the graph. Okay, but okay, I'm not a master of graphs, to be very honest, right? But n will be going something like this. N square will grow at a faster rate. N cube will even grow at a faster rate, right? So can I say this is the order of increasement, right? N cube is the worst, n square is somewhere in between, and n is the best out of these 3, right? Can I tell you? And logic you are understanding, right? We are looking at larger values of n. At large values of n, at large values of input, n cube will be scaling or increasing at a much faster rate as compared to n square and n. Okay, so at large values of n, asymptotically, this is better than this, and this is better than this. Okay, now I'll ask you to compare. Can you compare these two for me? Can you compare these two? Can you compare these two for me? No, log n. Okay, log n or n, which one? Can I place the arrow like this? Do you agree? Boss, let's say you are finding the log, right? If n ka value becomes very large, let's say n is 2 raised to 35, suppose. And if I am finding log n to the base 2 of this, what will be the answer? Log n will be just 35, whereas n is equals to 2 raised to 35. Are you getting this? Yes. See, if n is equal to 1000 and we are talking of log n to the base 10, what will be log 1000? What will be log 1000 to the base 10? 3. है ना? 3 होगा ना? So do you all agree log n will be growing at a much slower rate as compared to n. And if you look at the graph, सब चीज graph से clear हो जाता है. N is like this, and log n will be going somewhere, if I am not wrong, like this. So at large values of n, right, n will be increasing at a much faster rate as compared to log n. So log n is better. Okay. I have shared the article, shared the links, so definitely, right? Definitely. Okay. Another thing. Log brief कर दीजिए. Log is boss a function. Log function क्यों use करते हैं? Because if you have a look, we had discussed something like this, right? Yes, we had discussed something like this. What was the runtime of this? This was log n base 2, right? So there are certain codes which have log n runtimes. Okay. And what did I tell you for this? I starts at the value n. Okay. Then it goes to n by 2. Okay. Another time the loop runs. Then it goes to n by 4. Loop runs. ऐसे करते करते it will go till n by 2 raised to k and the loop will run. So let's say this is the first, second, and this is the kth time. So what is n by 2 raised to k? It is equal to 1. So k will be equal to log n to the base 2. So 1, 2, 3, 4 till k. So these are k bubbles and this is one more. So k plus 1 times the loop has run, which is log n plus 1, which is nothing but log n. Okay, that is why we study log, right? Because you have codes which have log n time complexity. Okay. Now help me to compare these two. अरे यार slides खत्म हो जाता है बार बार. 1 second guys. We'll try to take interesting, questions only today. I'll try to keep it as good as possible. Okay. Anyone help me? Compare these two for me. एक काम करो, अगर नहीं समझ में आ रहा है ना, कैलकुलेटर लेना and take a very large value of n and see which is greater. Can you help me? What sign? What sign? Greater than or less than? No. Greater than. It will be greater than, right? If you look at very large values of n, now root n will be growing at a faster pace as compared to log n. Okay. Root n is greater than log n. Why? Let us try to take, right? I want to compare root n and log n. What will I do? I take log on both sides. Take log on both sides. What will be log of root n? अब मुझे नहीं पता, देखो इसमें थोड़ा मैथ्स चाहिए होगा, but let's see how many of you understand. What is log of root n? Can I say log of root n is nothing but half log n? Can I say half log n? And on the right hand side you have log of log n. Yes, agree? And I am comparing these two. Now guys, try to understand. If you take n very large, log n उसको छोटा कर देगा, right? And again you take the log of a smaller number, it will become even smaller. So here you are performing log 2 times, but here you are performing log once and dividing by 2. So definitely performing log 2 times will reduce the number at a much faster rate. Okay. Making sense? समझ आ रहा है? See, root n and log n, take log on both sides, right? Log of root n will be, what is log of root n? Log of n to the power half, that is half log n. Okay. How to get knowledge of log? We need very basic knowledge. Just read up something about log, the properties of log, right? So half log n, and on the right hand side you have log of log n. So if n is very large, right? So what will happen? When you do a log, it reduces, and then you divide by 2 here. But here, you after taking a log, you again take a log. So this is greater, right? So if this is greater, definitely this will be greater. If this is greater, this will be greater. So can I say root of n is greater than log n? So big O of root n is worse than big O of log n. Everyone agrees? Yes? Okay. So now, if I want to, rate, or if I want to put together all the, time complexities that we have discussed till now, okay, I just want to put it out. Okay, later karte hai, wo theek hai, later karte hai. Now I'll ask you a question. 1 sec. Yeah, help me guys. Help me. I tell you, boss, you have a function f of n, which is running in n when n is less than 1000. Okay. And it is running in n square when n is greater than 1000. Okay. And you have another, okay, let's talk of this. So can you tell me the asymptotic analysis, asymptotic notation? What is the worst case runtime of f of n? What do I say? Do I say big O of n, big O of n square? What? Big O of n square. Do you know why? Because in asymptotic big O notation, we look for large values of n. I will say that what happens when n is very large? For very, very large values of n, you will see that the runtime is n square. So the worst case is big O of n square. Okay, let me give you another. Let's say you have a function g1 of n, which is equal to n when n is less than equal to 100. Okay, this is the runtime. And it is n to the power 4 when n is greater than 100. And you have another function g2. Okay, I have done around 600 questions in LeetCode. Okay, and let's say g2 of n is another function which is running in n cube when n is less than equal to 100, and it is running in n square when n is greater than 100. Can you tell me the worst case runtime of n, g1 plus g2? G1 plus G2. Can anybody help me? Can I say G1 plus G2 is nothing but big O of n raised to 4 plus n square, which is nothing but big O of n raised to 4. Do you all agree? Agreed? Mante ho? Yes? Because we are only interested in large values of n, right? So look at large values of n. What happens at large values of n? G1 of n is giving you big O of n raised to 4. And G2 of n is giving you n square. So in totality, what will they give you? N to the power 4 plus n square, which is nothing but big O of n raised to 4. Making sense? Yes? Okay. Now, I also wanted to discuss, a couple of questions. Okay. Let's me try to give you a code and tell me the time complexity. When we do real world problem, do we need to find time complexity every time? Technically, Gaurang, like I'll tell you my time in the industry, I have never found a time complexity in industry in the last 1 year, right? We see in industry now, they are more worried about the correctness rather than the speed. Okay, थोड़ा सा double काम भी कर लोगे ना, but output सही आना चाहिए. That is more important. But yeah, for entry and interviews, we need it. Very important. Okay. Okay. Let's look at this. Okay. Now I'll give you a code. Can you tell me the time complexity? I am finding the maximum of two numbers. What if for G2 n less than equal to 100 and n raised to 5? Still that will get ignored, right? Because I am only interested in large values of n. Okay. Can anybody help me with the time complexity of this code? A and B are my inputs. I will say it's a constant time complexity. Constant time complexity, because irrespective of how large A or B is, you are just doing a normal if-else comparison. Do you all agree it is big O of one time complexity? Constant time complexity. Achha. I'll give you a couple of other examples of constant runtime complexity algorithm. If I ask you to swap two numbers, yes, correct, Anmol. If I ask you to swap two numbers with the help of a third variable, do you agree that swapping two numbers is also a constant time complexity algorithm? Do you all agree? आता है ना सबको swapping करना? Swap का code लिख के देखो तो. Do you do any loops? Do you do anything? Do you depend on the size of the variables? Never, never. So that is big O of one time complexity. And I give you another question. Okay, I tell you, boss, you have an array. Okay, you have an array of size n. ध्यान से सुनना. You have an array of size n. Can you tell me the sum of the first and the last element? Can you give me the sum of the first and the last element? Can you tell me the time complexity? Sum of the first and the last element. You have an array of size n. Anyone? Constant, guys. What will you do? You will simply return what? You will return ARR of 0 plus ARR of n minus 1. So is it not constant? You just inspect this. You just inspect the last thing. So that is constant work that you are doing, right? So this is also big O of one time complexity. Making sense? समझ आ रहा है? कितने लोगों को समझ आ रहा है? Yes? Okay. Okay. Now, can anybody help me? Let's say you have a matrix. You have a matrix. Okay. I'm just drawing random things, right? Which I remember. Let's say you have a matrix. It's a general thing to strengthen up your concepts, right? If I want to print this matrix of m rows and n columns, what will be the time complexity for printing this matrix? M rows and n columns. Correct, guys. Big O of m into n. Do you all agree? Look at the code. You run a loop for int I equal to 0, I less than m, I plus plus. Run an inner loop for int j equal to 0, j less than n, j plus plus. Then you print ARR of ij or mat of ij. So does everyone agree? Iterating over a matrix is big O of mn time if m rows and n columns are there? Yes? Okay. 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 Now help me with this code, guys. Help me with this code. You will tell me the time complexity, right? Yeah, it's asked. It's asked. पूछ सकते हैं. There's nothing. Matrix hasn't done any wrong to not get asked in the interview, right? Guys, can you help me with the runtime of this? Okay, interesting. N square. Okay. Now, what did I tell you? Nested loops generally is n square, right? But there can be catches, there can be exceptions, there can be tricks. This is not n square. This is not n square, guys. Take your compiler, write here SOP hello, okay? And tell me how many times hello is printed. करके देखो तो एक बार कोड लिखो कंपाइलर पे जाके. ये कोड लिखो, right? For int I equal to 0, I less than n, I plus plus. For j equal to 0, j less than n, j plus plus. Print hello and then break. See how many times hello is printed? It will be printed only n times. So even though you see that these are two nested loops, the runtime is big O of n. Because ये loop है ना, this is the artificial loop. Artificial loop. Why? Because the moment you enter into the loop, now you break. So this loop will always run once. So let us see what happens. I go on to my fundamental technique. For I equal to 0, how many times will the inner loop run? Can you help me? The inner loop runs only once. You print hello and you break only one time. Okay? For I equal to 2, how many, for I equal to 1, how many times will the inner loop run? Only once, boss. You enter and you break only one. For I equal to 2, again it will run once. For I equal to n minus 1, again this inner loop will run once. So how many operations are there, boss? 1 plus 1 plus 1 plus 1 plus 1. And how many times have you added 1? N number of times. So it is not big O of n. सोच के बताओ, guys. Are you clear with this? This kind of question was asked once in a very big MNC, right? I'll not name it on air, but this kind of questions got asked. This is a trick question. Okay. Big O of any boss. This is not a loop. This is not a loop. This is as good as doing this. See, it is as good as doing this. I plus plus, you just print hello. It is as good as doing this, boss. Because what are you doing in the inner loop? Entering, printing, breaking. Dummy loop hai wo. Yes? Everyone clear? Just be focused on calculating the number of primitive operations. The best way to solve any problem. Right? Okay. Help me with this one. Break nahi hota to n square ho jata. Correct? Correct. Okay. Now I will ask you all. Okay. Switch case kab karoge? Okay, guys, I'll try to cover switch case. If not, I will record a video of half an hour for switch case and circulate among you all. Don't worry, I will do everything. है ना? सब कराऊंगा. थोड़ा time मिलने दो. Otherwise, I'll record 30-40 minutes video and circulate it. Right? It's easy. Okay. Now, primitive operations, basic operations, writing in array, changing the variable values, and all these things. Right? I don't want any one of you to jump to answers immediately. Take a piece of pen and paper, calculate the number of operations. Okay. I am more interested in the number of operations. Okay, guys. Can you help me? Can you help me? Can you help me? What is the time complexity of this code that I have written? Okay. So you are saying n, that's fine. But can you give me the exact number of operations? अब मैं question tough कर देता हूँ. Give me the exact number of operations. Take a piece of pen and paper and tell me the exact number of operations that are getting performed. I am more interested in that. If somebody is able to give me that, I will be very happy. Exact number of operations. N square, n into n. Okay, don't write it. Take a piece of pen and paper and tell me. Exact number of operations. I am still waiting for an answer. Correct answer. N minus 1. Okay. N. See, the answer is it is big O of n. For sure. It is big O of n. कैसे पता चलेगा? Nested loops है, break भी हो रहा है. I don't know. I will resort with my normal technique. Now let us start, right? For I equal to 0. For I equal to 0. Can you tell me, boss, how many times does the loop run? How many times does the inner loop run? Help me. For I equal to 0, the inner loop will run for n. No. The inner loop will run how many times? See, if I is less than n minus 1, it will immediately break. So can I say for I equal to 0, the inner loop will run only once? Can I tell you? Do you all agree? For I equal to 0, the moment you enter, you will see 0 is less than n minus 1, you will break. Yes. For I equal to 1, how many times will the inner loop run? Again once. Okay. ऐसे करते करते, do you agree that till the value of I is n minus 2, the inner loop will run only once? Do you agree? यहाँ तक? But now see, for I equal to n minus 1, what will happen? Can you tell me how many times does the inner loop run? For I equal to n minus 1, this if condition will not be satisfied. So the loop will run for n times. N times, boss, you will never break. So this loop will run for n times. So now if I ask you the total number of operations, what is it? 1 plus 1 plus 1 plus 1 plus 1. How many times I have added 1? I have added 1 how many times? N minus 1 times. Okay. And the last time for I equal to n minus 1, the inner loop runs for n times. So plus n. So what is it? When you add 1 for n minus 1 times, you get n minus 1 plus n. So it is 2n minus 1 operations. Okay. So it is big O of 2n minus 1, which is nothing but big O of n. Is it making sense? By dekho guys, try to understand. When the value of I is lesser than n minus 1, what will happen? For I equal to 0, you enter inside the loop. You see that boss 0 is less than n minus 1, so I will break. So this loop only run once. Mante ho? Dekho na, for I equal to 0, you enter here, you enter the if block, you simply break. Okay? So the inner loop runs only once. यहाँ तक किसको समझ में आ रहा है? पहले ये बताओ. Is everyone clear with this? For I equal to 0, the inner loop run only once because you enter the if block and you break. Similarly, till the value of I is n minus 2, okay, you enter this loop, this condition, n minus 2 is less than n minus 1, this will be true. You enter the if block and you break. So for all values of I starting from 0 till n minus 2, the inner loop only run once. Do you all agree with this? Yes? Huh? सही है? अब देखो what happens. Then I will take a value of n minus 1. Now take the case that I is equal to n minus 1. You enter the loop. Is n minus 1 less than n minus 1? No, it is false. So you will not enter inside the if block. You do a j plus plus. Value of j will increment. Again, you will check. Has I changed? No. Move forward, move forward, move forward, move forward, move forward. So for I equal to n minus 1, this inner loop will run for n times. So n times लिख दिया. Now, how many times has these operations been performed? Add up all these things, right? So n plus 1 plus 1 plus 1 plus 1 plus 1. So how many times I am adding 1? For I equal to 0 till n minus 2. So how many different values of I are there? N minus 1 value. Dekho na boss. 0, 1, 2, 3 till n minus 2. So these are n minus 2 plus 1 for 0, right? So I am adding 1 n minus 1 times, okay? And then for I equal to n, I am adding 1 n at the end, okay? So how many operations? N minus 1 times I am adding 1. So this sums up to n minus 1 plus n. So this is nothing but 2n minus 1. So it is big O of n only. Is it making sense, guys? कितने लोगों को समझ में आया? Just focus on the interesting part, right? मतलब the major part. That will help us to understand, right? Okay. Okay, cool. हाँ कराऊंगा और क्वेश्चन कराऊंगा, ठीक है? Not getting for n minus 1. After n minus 1, the case will be n less than n. No. After I equal to n minus, do you get this part? That for I equal to n minus 1, the inner loop runs for n times. है ना? मानते हो? ये बात मानते हो तो हो गया ना? Because the value of I will not go after n minus 1. Okay. If the value of I is n minus 1, the inner loop will run for n times because you will not enter inside the if block and break. Okay. Cool. Acha, one thing, guys, I see time and again people have this confusion कि this loop, बहुत लोग बार बार बोल रहे हैं कि this runs for n minus 1 time. No, boss, this loop run for n times. I will take values from 0 till n minus 1, and for every value of I, the loop is running, right? So how many different values are there? N different values, boss. From 0 till n minus 1, there are n different values. So n times loop run hota hai na? How 2n minus 1? No. You are getting confused. From 0 till n minus 2, this condition will be satisfied, guys. Try to understand. For I equal to 0 till n minus 2, this inner if block will be satisfied and you will simply break. Break हो जाओगे ना? तो एक बार ही चलेगा. And for I equal to n minus 1, you do this. Okay? Cool. So if I want to less than, no. Why? Okay. Now, if I want to discuss, okay. So we have had a look at big O of n. Okay, we know big O of n. This is linear time complexity. Linear. Okay. Just 1 second. 1 second. It's linear time complexity. Then what did we had a look at? We had a look at n square code. हम लोग n square भी देखे, right? Big O of n square. Okay. This is quadratic. Okay. Then we had a look at O of n cube. That was cubic. Okay. Then O of log n we saw. Log n type complexity. This is logarithmic. Then we saw big O of n log n also we saw yesterday. Okay. Then we saw constant runtime also, big O of 1. Okay. We also saw root n. We also saw root n, right? Big O of root n. Okay. Now, can you help me in arranging all these things? Can you help me in arranging? Okay. So first of all, big O of 1 is the fastest. Okay. After this, what should I put from this list? Can I put log n? Log n? Yes. Now, after log n, what do I put? After log n, anybody help me? Anybody? Root n. Root n. Root n, boss. Root n. है ना? Because root n is less than n ना. So n के तो पहले ही आएगा. So root n. Okay. Then after root n, what should come, guys? Can you help me? N. N. Boss, n आएगा ना? Big O of n. Then after n, what should come? N log n. Okay. Then after n log n, what should come? Big O of n into n. That is n square. Then you will get big O of n cube. Okay. And we have not discussed something, but something is also, exponential. ऐसा 2 raised to n, 3 raised to n. Okay. So these are mostly the worst case. सबसे bad होता है ये. ठीक है. So big O of 2 raised to n. Then you will have big O of 3 raised to n. And then you will have big O of n raised to n. These are very, very bad things, right? 2 raised to n, 3 raised to n. N raised to n तो नहीं काम पड़ेगा ज़्यादा. Forget it. But yeah. So is everyone understanding this part? The comparison of different functions? Yes. This is the fastest, then log n, then root n, then n log n, n square, n cube, then, exponential time complexity starts coming. Okay. Everyone clear till here? Root n or log n. Compare किए तो थे अपने root n log n. That is why I compared root n and log n earlier only. Okay. Cool, guys. Okay. That's great. Now I'll give you a question. You will solve. Okay. You will give me the answer. हाँ मैं लेता हूँ. Durga, just keep the question intact. I'll ask you for the question. I'll discuss everything today. But first of all, I want you guys to solve a question for me. Okay. यार एक और तगड़ा थोड़ा मैथ्स का क्वेश्चन था. I have skipped it for the time being because I thought that will be too much maths for you. But ठीक है, देखते हैं बाद में कभी मन हुआ तो बता दूंगा. But that's basically like abhi tak what kind of n log n we saw? What kind of n log n we saw? This was n log n, right? Look at this code. What is this? This is n log n, right? This is n log n, right? This was n log n, right? Okay, great. Everyone agrees. That's fine. Help me with this code, right? This is this entire part. Okay. And then later, I am making a array. Can you guys help me with the time and space complexity of this? N is my input. Time complexity should be very easy for you guys to tell. What is the time complexity? Log n to the base 2. Everyone agrees? N कौन बोल रहा है? N जो भी बोल रहा है बहुत मारूंगा. N मत बोलो यार अब. Time complexity is log n to the base 2, right? Because I is getting divided by 2 at every step. And that while loop is controlling your time. So time complexity is log n. Everyone agrees, right? Can you help me with space complexity this time, guys? I'm more interested in the space complexity. For sure, this space complexity is not big O of 1. Why? Because we're making a new array. And what is the size of the array? A. So you can say that the space is big O of A. But I want to find A as a function of n. मेरे को answer देना है n में. ठीक है? And do you guys agree that A will be dependent on the value of n only, or the value of I only, whatever? A will depend, na? A will be dependent on n. Try to see, guys, what are you doing? Let us look at the code, right? फिर से slide खत्म हो गया. Just 1 second. So I'll just take 15 minutes more of your time. Then you are good to go. Okay. I'll just quickly discuss this question. One question somebody asked in the chat, that one, and one question from interview bit. And then I think we should be good. Okay. Okay. Just 1 sec, bro. Yeah. So I am more interested in knowing the space complexity. So मेरे को बताओ, guys, I am making an array of size A. Do you agree? I am making an array of size A at the end. So can I say my space complexity is big O of A? So if I know what is A in terms of n, I can tell you the space complexity. So now let us see what is happening with the variable A. Let us try to understand what is happening with the variable A. So first of all, the value of I is n, and what will get added to A? N will get added to A. Do you agree? The value of I add kar rahe na, so n gets added to A. Then the value of I will become n by 2, and I will add n by 2 to A. So now the value of A will become n plus n by 2. Then what will happen? The value of I will go to n by 4, and you add n by 4. Then the value of I will go to n by 8, you add n by 8. Then it will go to n by 16. Likewise, till the value of A becomes 1. Do you agree that this will be the value of A outside the while loop? What are you doing? See, you are just adding the value of I to A. So first of all, you will add n, then you will add n by 2, then n by 4, then n by 8, then n by 16, and something like that. So if I'm able to calculate this sum, okay, I know what is the space complexity. And somebody has identified very correctly. This is an infinite GP. Okay. See, take n common. Take n common. What do you get? 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16. ऐसे करते करते 1 by n. And what did I tell you? We are interested in large values of n. So can I say, boss, do you identify this is a GP with the first term as 1 and common ratio as half? मेरे को नहीं पता कितने लोग पढ़े हो GP maths में. But this is a geometrical progression, right? There is a common ratio, right? 1, you multiply with half, you get to this. Then you again multiply half, you get to 1 by 4. Then you multiply half, you get to 1 by 8. Then you multiply with half, you get to 1 by 16. So the first term is 1 and the common ratio is half. Okay. And there are infinite number of terms if I consider n to be very large. So what is the summation formula of an infinite GP? It is first term by 1 minus common ratio, which is half. So this entire summation, I can approximate it to be 2. Okay. And into n, so 2n, right? So this entire thing, rough approximation will be 2n. So A is nothing but 2n. So can I say the space complexity is nothing but big O of 2n, which is nothing but big O of n? Do you agree? कितने लोगों को समझ में आया ये part? What is it? This is a GP, right? First term is 1, and GP is necessary for certain things, right? You just have to understand, right? See, every term is getting multiplied by half. 1 tha, you multiply half. Again, you multiply half, multiply half, multiply half. Okay. Just read the basics of GP. That will work. उससे ज़्यादा नहीं चाहिए अपन को. ठीक है? So does everyone agree that the time complexity is big O of log n and the space complexity is big O of n? Do you all agree? Yes? Okay. Now, anybody, someone was giving a question, right? Someone was giving a question. Okay. Let's go. Let's go to interview bit. I wanted to discuss a question from there. Okay. To give you confidence, to give you no data available. Right? Okay. Guys, can you open interview bit? Open. If you want to open, you can open parallelly. We'll solve one question. And I'll just, you will solve, not I, you will solve. No data. Pata nahi kyun hua. Okay. Ab, come to this part. Okay. So I'll ask you to solve this question. See the company tag? Bada company hai na? Right? Good company. Almost many of the people will have their dream companies, right? Let's go it and try to solve it, right? Ab tum log karoge. You know the fundamentals. You try to solve, bro. Try to help me. देख के nested loop लग रहा है, right? देख के you see that it is a nested loop and you are tempted to take n square. But what I will suggest you is we have learned the fundamental technique. Can you guys spend a couple of minutes and give me the answer? I will be very happy if you are able to give me the fundamental answer. Just calculate the number of operations. Calculate the number of operations. Don't jump to n log n. कैसे n log n होगा? Don't jump, right? See, the inner loop is not running n times. Okay, it's running up to I. It's not n log n. Okay. See, this loop is running for log n times, but the inner loop is not always running till n. Right? That's a beautiful thing. Chalo, theek hai. I will go to my fundamental techniques and then I will ask you, is this question easy or difficult? Tell me, guys, when the value of I is n, how many times will the inner loop run? J equal to 0, j less than n. How many times will the inner loop run? N times. Do you all agree? Yes? Sab log mante ho, when the value of I is n, the inner loop will run for n times. Yes? Okay. Then when the value of I, iske baad what will be the value of I will go to n by 2. Arey no kaise? No kaise bhai? See, if the value of I is n, what happens for the inner loop? J equal to 0, j less than I, which is j less than n, j plus plus. How many times is this running? N times, na boss? So when the value of I is n, the inner loop run for n times. Now when the value of, acha dekho na, the inner loop actually runs for I times. So when the value of I is n by 2, how many times does the inner loop run? Mante ho? Yes? Then the value of I will go to n by 4. How many times does the inner loop run? N by 4. Then the value of I will go to n by 8. How many times the inner loop run? N by 8. ऐसे करते करते you will reach 1 and the inner loop will run once. Do this summation, boss. Did we not do it just now? N plus n by 2 plus n by 4 plus n by 8 plus n by 16 plus n by 32 till 1. Is it not a GP that we have just now evaluated? And what was the answer? 2n. So it is big O of 2n or big O of n. देखते हैं option है क्या? Let's go down and see. Big O of n है क्या option? है. Okay. Take it. Submit it. See? Correct answer. That is why I focus on fundamentals, right? If you are able to calculate the number of operations, you will never go wrong. Otherwise, you can sometimes be tricked. Log n, n. But ये n नहीं है. This is running I times. This is not running for n all the times. That is the catch here. Okay? That is the catch here. Everyone clear? How many of you are clear? 5? Okay. Again. See, you just have to see how many times the inner loop is running. So the inner loop is running for I times, right? And what are the values of I? First of all, I takes the value of n. Then I will take the value of n by 2. Then I will take the value of n by 4. Then I will take value of n by 8. Every time the value of I is getting divided by 2 till you reach 1. So what is this summation? You take n common. It is nothing but 1 plus half plus 1 by 4 plus 1 by 8 plus 1 by 16 till 1 by n. This is an infinite GP. है ना? What about outer loop? Boss, we have taken the outer loop into account, right? I have taken, first I have taken the value of I as n, then n by 2, then n by 2. No, it's not an infinite loop. Why? n से start होके 0 पे जाएगा और खत्म हो जाएगा, है ना? No, not infinite loop. Why? Okay. So this is a by 1 minus r, which is 2. So 2 into n is 2n. Okay. Is everyone clear? It's not infinite GP. Correct, Neil. But what did I tell you? Approximation. Approximation is a very important game. Very, very large value of n. What if you have a very large value of n? You are definitely looking at infinite number of terms. You can simplify your calculation, right? Otherwise, apply the normal formula. You will still get big O of n only. Okay. One more. Okay. Now, guys, I have one question. I am not very sure if you want to do it or not. That is a mathematical based question that requires integration knowledge, right? But if we do that, I will be satisfied that I have covered all types of questions. So do you want to do it? It will be infinite loop. Why? I greater than 0, है ना? So 0 greater than 0 will become false, है ना? Okay. So do you want to do it? It will take another 10-15 minutes. If people are interested, I can do. Otherwise, I can skip. Do? Chalo kar lete hain. Thank you, guys. So you are interested? Okay. People who want to drop off, right? You can drop off. It's a little bit advanced question, right? It will involve integration, but I'll try to break it down in as simple way as I can, right? I'll try it in the best possible way. Okay? चलो कर लेते हैं फटाफट. ठीक है, उसके बाद मेरे को satisfaction आ जाएगा. Otherwise, I will have this thing in me that okay, अरे क्या हुआ? Okay. Now we have a small problem. I don't see my bottom of the screen. Okay. Anyways, I will do. Yes, we used I, Sharma. Try to understand. मैंने I का value n लिया. Then the inner loop ran for n times. See, ultimately you have to see how many operations are getting performed because of both the for loops. So we have taken into account, right? अगर मैं outer for loop को नहीं लेता ना, then I would have just told you the inner for loop runs for let's say n times. But we took different values of n ना. कि I is equal to n, inner loop runs for n times. I equal to n by 2, inner loop runs for n by 2 times. So for all these different values of I, what are you doing? You are simulating the outer loop only, na? Okay. How will n reach the value of 1? Definitely will reach 8 के बाद 4 जाएगा, 4 के बाद 2, 2 के बाद 1, 1 by 2 will go to 0. So ultimately everything will terminate. Okay. Now help me with this, guys. Help me with this. I am not sure I can go to the PPT. I am unable to see it, but just help me with this. This is the interesting question that I was talking about. Last question for the day. Okay. And no force from my side. If anybody wants to drop off, you can. Alt plus tab. Oh, interesting. Thank you. I think I am like thoda sa technologically, challenged. But yeah, anyways. Okay. Let's come to the next. What happened? Something is bad. Oh, sorry. Yes, let's come, right? Yes. Recording will definitely be there. So if you want to drop off, you can drop off, right? Help me with this code. Last question for the day. And I hope that today's question must have made time and space complexity a little bit more clear. MS1 no. I haven't tried it any time. Like, can try. मेरे को PPT अच्छा लगता है, पता नहीं. Don't jump to conclusions, right? And I am not also expecting that you give me the correct answer, but at least tell me the number of operations. Last question for the day. Yes, guys. I am more interested in the number of operations, right? I'm not interested in the time complexity. You just tell me the number of operations. देख के n square लग रहा होगा ना? Two nested loop n square, but it's not n square. Okay, that's why I told na the best way is to count the number of operations, and I generally just do that only. Okay, can anybody help me? Anybody, can you help me? Okay, chalo. I don't want to waste time here. It's already running out of time. So can you tell me for I equal to 1, how many times will the inner loop run? Can anybody tell me? For I equal to 1, how many times will the inner loop run? Help me. क्या होगा? J equal to 0, J equal to 1, J less than equal to n, J plus equal to 1. So what will happen? First J will take a value 1, then 2, then 3, then 4 till n. So does everyone agree for I equal to 1, the inner loop run n times? Does everyone agree? Yes? सब लोग मानते हो यहाँ तक? Right? Now what will happen? Now next I will take a value of 2. Now for I equal to 2, can you tell me how many times the inner loop runs? If you are able to tell me, you get the question. How many? N by 2 times. Correct, guys, because J will start from 1, go till n, but this time you are incrementing J by 2. So first J will take a value of 1, then 3, then 5, then 7, then 9, likewise. So you are skipping every other value. So the inner loop will run for n by 2 times. Do you agree? Does everyone agree? मानते हो क्या? See now, what are you doing? First of all, you are running for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say you ran it for I equal to 1. So it ran for 10 times. But when the value of I will become 2, J will take a value of 1, then 3, then 5, then 7, then 9. So are you not reducing the number of times the loop runs? Yes, you are definitely, right? Then when the value of I is equal to 3, what are you doing? What are you doing? 1. Then you will skip 2 values, go to 4. Then you will skip 2 values, go to 7. So you are taking every third value. So the inner loop runs for 3 times. So do you agree, guys? Do you agree that for I equal to n, ऐसे करते करते n पे आते हैं, for I equal to n, how many times will the inner loop run? Only once, only once, only once. देखो ना, j equal to 1 पे start हुआ, 1 less than equal to n, run once. And then when you add n, j will become n plus 1 and the loop will no longer run. Okay. So now, yes, Neil, you are correct. So if I want to compute the number of operations, can I say the number of operations is nothing but n plus n by 2 plus n by 3 plus n by 4 plus n by 5 plus n by 6 till 1. Do you agree? If I know this answer, my job is done. Khatam. Question yahi hai. Big O of this is my answer. I just want to summarize this thing. Do you all agree? Yes? Do you all agree? yahan tak pakka hai sab log? Correct, guys. Now you will understand what I am wanting to do. Okay. Now let's say I take n common. I just take n common, right? See, I am interested in evaluating this summation. Okay. N plus n by 2 plus n by 3 plus n by 4 plus n by 5 till 1. I am interested in evaluating this summation. What do? I take n common. I take n common. So 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6 till 1 by n. अब मैं एक तुम लोग को चीज बताता हूँ, ठीक है? Now comes the mathematical part. What is this integral? Can anybody help me? What is this integral? यहाँ पे आता है थोड़ा सा. Is it log n? Is it log n? Is this answer log n? What is 1 by x integral? ln x, and you substitute the values log n minus log 1. सबको आता है ये? Log 1 is 0, so answer is log n. Does everyone agree with this? Yes. So if you now understand the physical meaning of integration, what is the true meaning of integration? Ki boss, x will take values. It is the summation of 1 by x, where x varies from 1 till n. Do you agree? What is this telling? I am adding 1 by x. I am adding 1 by x, summation of 1 by x, right? Where x varies all the way from 1 to n. Yes, all the real numbers from 1 to n. So can I write this sum like this? 1 by x ka summation hai na? So 1 by 1 plus 1.00001. See, x is varying all the way from 1 till n, 1.5. There will be infinite terms, right? Obviously. 1.75, 1 by 2. Are you understanding what I'm wanting to say? X will take all values from 1 till n. That is the summation. Okay. Yes. X is continuous, correct? That is why I'm saying that there are infinite terms. I cannot write all the terms. Okay. I cannot write all the terms. But do you agree? Do you agree? There are infinite number of terms, right? And the summation is log n. Now what I am telling you, if I remove all these terms and I just focus on 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. So can I say this summation will definitely be less than log n? Boss, dekho na, the summation of the infinite terms was log n. Now, if I remove some terms and I just focus on 1 plus 1 by 2, 1 by 3, 1 by 4, 1 by 5, is the summation not less than log n? Is the summation not less than log n? So can I say log n is an upper bound to this summation? This summation can never be greater than log n. It is lesser than log n. Okay. So what do I say? In the worst case, we talk about the upper bound. कि इससे ज़्यादा तो हो ही नहीं सकता. So I tell you, this summation is never greater than log n. The upper bound of this summation is log n. So the upper bound for this entire expression will be n into log n. This is the upper bound. Upper bound. इससे ज़्यादा कभी नहीं होगा. So I will say the worst case runtime is big O of n log n. This is the upper bound. Is it making sense, guys? Is it making sense? This was the last question that I wanted to discuss. Yes? You use GP? You can, but it's a better approximation, right? It's a better approximation. तुम अगर GP use करोगे, now try to understand, guys. If you used GP, okay, then you will say that, this summation is n, and you will say n into n square. But I am telling you it's n log n. See, you understand n square and n log n, right? If I say big O of n square, if I say if my code is big O of n square, now, so that is fine, okay. But मैं क्या बोलना चाह रहा हूँ? I'll try to frame it correctly. If my code runs in n log n, see, again, try to understand. If my code runs in n log n, and if you report n square, you are not doing anything wrong. Okay, it's a more safer estimate. But in big O notation, we look for the nearest upper bound. Look via graph, what I am trying to say. If there is one graph, there is two graph, there is this third graph, there is this fourth graph, right? And my code is running in this time. My code is running in this time, right? And if I want to give an upper bound, so I can say it is big O of this. Let's say this is F1. I can say it is big O of F1. I can also say this code is big O of F2. इसका मतलब क्या हुआ? The code's worst case runtime is F1 or F2. Upper bound है, ये इसको घेर रहा है ऊपर से. But whenever we talk of big O notation, ना, we look for the nearest upper bound. So you try to understand, guys. You can say n square, but n log n is a closer upper bound. So you will have to report as big O of n log n. है ना? You can't do GP here. Yes, R is not constant. है ना? Getting the point what I'm trying to say? The big O notation is the nearest upper bound. Upper bound है कि उससे ज्यादा टाइम नहीं लगेगा. But मैं ऐसा तो बोल सकता हूँ ना, if something is taking 10 minutes is the worst case. मैं बोल सकता हूँ worst case 20 minutes है, worst case 15 minutes है. But no, we report the worst case as 10 minutes. It's the nearest upper bound. Okay. No, you cannot use GP because there is no common ratio. Okay. Cool, guys. So I will just take one last poll and I will expect all of you to just participate in that. I'll just stop the recording. Okay.